everyone, welcome to your favorite channel PrepMed NEET. আমি ডক্টর দেবজ্যোতি আর NEET 2026 এর আগে প্রত্যেক বছরের মতো এবছরও আমি একটা পুরো কমপ্লিট জুওলজির একটা ম্যারাথন সেশন নিয়ে চলে এসেছি আর আই হোপ আমাকে সবাই প্রপারলি শুনতে পাচ্ছে এবং আজকের রাতের এই যে ম্যারাথন সেশনটা আজকে আমি করাবো এটা এই সেশনটা একটা ভীষণ স্পেশাল সেশন বিকজ এই সেশনে আমি কমপ্লিট চেক লিস্ট অফ কমন মিস্টেক এরিয়া আমি প্রত্যেকটা চ্যাপ্টারকে ধরবো এবং সেই প্রত্যেকটা চ্যাপ্টারে কমনলি কোথায় কোথায় ভুল হয় কোথায় কোথায় মিস্টেক হয় সেটা আমরা আজকে শুনবো আই হোপ আমাকে প্রপারলি শোনা যাচ্ছে ইয়েস গুড ইভিনিং পর্ণবকে মেনি কংগ্রেচুলেশন পর্ণব খুব ভালো রেজাল্ট করেছে আমি জাস্ট একটু আগে শুনছিলাম তো যাই হোক আমরা চলো স্টার্ট করা যাক আজকে সেশন প্রথমে তোমরা দেখতে পাচ্ছ অ্যানিমাল টিস্যু দিয়ে উইল স্টার্ট ফার্স্টে আমরা 11 এর পার্টটা করব এবং তারপরে আমরা ক্লাস 12 এর পার্টটা করব এবং পুরো জুলজি পার্টটাকে আমরা রিভিশন করব তো প্রথমেই দেখতে পাচ্ছ এখানে কিছু সেন্টেন্সেস আছে আমি চাইবো যে এই সেন্টেন্সগুলোর ব্যাপারে সবাই জানো খুব ভালো করে সেন্টেন্সগুলো ট্রু না ফলস সেটা আমরা দেখব আমি আজকে কোয়েশ্চেনের থেকেও বেশি ফোকাস করব কমপ্লিটলি সেটা হচ্ছে কনসেপ্ট রিভিশন করানোর দিকে কারণ এর আগে কোয়েশ্চেন রিভিশন নিয়ে মাল্টিপল আমরা সেশন করেছি তোমরা বারবার মক টেস্ট দিয়েছো অনেক কিছু দিয়েছো কিন্তু এরপরেও লাস্ট মুহূর্তে সবসময় মনে হয় না সিলেবাসটা একটু কভার করে নিই তো আজকে আমি এক্স্যাক্টলি সেই রেসপন্সিবিলিটিটা আমি নিচ্ছি তোমাদেরকে সিলেবাসটা কমপ্লিটলি আমি কভার করিয়ে দিচ্ছি So first data, the cells are completely packed with little intracellular matrix. এটা আমাকে বলতে হবে for এপিথেলিয়ামের জন্য বলো এই সেন্টেন্সটা এপিথেলিয়ামের জন্য ট্রু না ফলস এপিথেলিয়ামের জন্য ফর এপিথেলিয়াল সেলস মনে রাখবে যে দে আর প্যাকড উইথ ভেরি লিটল ইন্ট্রাসেলুলার ম্যাট্রিক্স ইন্ট্রাসেলুলার না অ্যাকচুয়ালি কথাটা হচ্ছে ইন্টার ঠিক আছে কথাটা হচ্ছে ইন্ট্রাসেলুলার মানে সেলের মধ্যে ইন্টারসেলুলার ম্যাট্রিক্স অ্যান্ড সেটা এপিথেলিয়ামের জন্য ট্রু হতো কারণ এপিথেলিয়াম টিস্যুতে ম্যাট্রিক্স খুব কম থাকে এপিথেলিয়াম টিস্যুতে মেজরলি যেটা থাকে এপিথেলিয়াম টিস্যুর মধ্যে সেটা হচ্ছে বেসমেন্ট মেমব্রেনটুকুই থাকে খুব কম ম্যাট্রিক্স থাকে সো দিস ইজ অ্যাবসলিউটলি ফার্স্ট সেন্টেন্সটা হচ্ছে অ্যাবসলিউটলি true sentence মানে false হলো just because of this intra correct false just because of this intra okay simple epithelium is composed of a single layer of cells function as a lining for the body cavities like duct and tube তাহলে duct এবং টিউবের জন্য simple epithelium composed of single layer of cell function as a lining do you think this is simple epithelium তোমাদের মনে হয় যে কোনো duct বা যে কোনো আমাদের ধরো লেটস সে যে কোনো duct আমাদের ইস্যু তাই নয় ইভেন আমাদের জিআই ট্র্যাক্টেও মাথায় রাখবে ফ্যারিংস এবং রেকটাম এই যে দুটো জায়গায় যেহেতু খাবার খুব ভীষণ ফ্রিকশন করে তাই এই দুটো জায়গাতেও কিন্তু আমাদের স্ট্র্যাটিফাইড লেয়ার থাকে সেখানেও কিন্তু সিম্পলস থাকে না সো দিস স্টেটমেন্ট ইজ অলসো ফলস স্টেটমেন্ট যেখানেই তুমি দেখতে পারবে বডি ক্যাভিটি রয়েছে যেখানেই তুমি দেখতে পারবে ডাক্ট রয়েছে টিউব রয়েছে সেখানে অনেক মেকানিক্যাল ফ্রিকশন হয় তাই সেখানে সিম্পল এপিথেলিয়াম থাকে না সেই জায়গাটায় থাকে কম্পাউন্ড এপিথেলিয়াম সো সিঙ্গেল লেয়ার অফ এপিথেলিয়াম সেখানে থাকে না কিন্তু অন্যদিকে যদি কোনো জায়গাতে আমরা দেখতে পাই যে সিক্রিশনস হচ্ছে অ্যাবজর্পশন হচ্ছে জিনিসের তাহলে সেক্ষেত্রে কিন্তু সিম্পল লেয়ারে থাকবে উইথ মাইক্রোভিলাই থাকতে পারে মাইক্রোভিলাই ইজ দ্য মডিফিকেশন অফ দ্য সেল মেমব্রেন সবাই মাথায় রাখবে নেক্সট কোয়েশ্চেন Next statement, the cuboidal epithelium is composed of a single layer of cube-like cells at the top, correct? This is commonly found in duct and gland and tubular part of the nephron of the kidney, correct? একদমই তাই শুধু কিউবয়েডাল নয় উইথ ব্রাশ বর্ডার বা মাইক্রোভিলাই আই হোপ জানো 2024 এর প্রশ্ন এসেছিল যে পিসিটি এবং ডিসিটিতে কি ধরনের এপিথেলিয়াম থাকে দ্য আনসার ইজ কিউবয়েডাল epithelium with brush border and its main function are secretions and absorption একদমই তাই কিডনিতে আমরা দেখেছি কিছু জিনিস সিক্রিট করে আবার কিছু জিনিস অ্যাবজর্ব করে নেয় সেটা বিট পিসিটি বিট ডিসিটি বিট লুপ অফ হেনলি যাই হোক না কেন সো ইটস ভেরি ইম্পর্টেন্ট নেক্সট হচ্ছে দে আর ফাউন্ড ইন দ্য লাইনিং অফ দ্য স্টমাকের লাইনিং এপিথেলিয়াম রয়েছে ইন্টেস্টিনাল লাইনিং এপিথেলিয়ামে রয়েছে এবং সেটা সিক্রিশন এবং অ্যাবজর্পশনে হেল্প করে দিস ইজ অলসো ট্রু সেন্টেন্স তো যেগুলো ট্রু লিখলাম যেগুলো ফলস সেগুলোর পাশে এফ করে লিখে দিচ্ছি দে আর মেনলি মানে এপিথেলিয়াম আর মেনলি প্রেজেন্ট ইন দ্য ইনার সারফেস অফ দ্য হলো অর্গান লাইক ব্রঙ্কিওল অ্যান্ড ফ্যালোপিয়ান টিউব এটাও কারেক্ট। এই প্রসঙ্গে একটা কথা বলবো, কেউ আমাকে বলতে পারবে ব্রঙ্কিওলের মধ্যে যে এপিথেলিয়ামটা থাকে দ্যাট ইজ ভেরি স্পেশাল এপিথেলিয়াম, তার নাম কি? তার নাম হচ্ছে সিউডো স্ট্র্যাটিফাইড সিলিয়েটেড কলামনার এপিথেলিয়াম। আই রিপিট, যে ব্রঙ্কিওল শুধু নয়, ইনফ্যাক্ট ট্রেকিয়ার মধ্যেও, ট্রেকিয়া, ব্রঙ্কিওল বা ট্রেকিয়া, ব্রঙ্কাই, ব্রঙ্কিওল এর মধ্যে যে এপিথেলিয়ামটা থাকে সেটা হচ্ছে সিউডো স্ট্র্যাটিফাইড কলামনার সিলিয়েটেড এপিথেলিয়াম। মানেটা কি? মানেটা হচ্ছে, আই হোপ সবাই জানে, যে যদি দেখা যায় যে ধরো এইটা একটা সেল আর এর সামনের সেলটা এরকম ছোট্ট সেল, তোমার দেখে কি মনে হচ্ছে মানে একই বেসমেন্ট মেমব্রেনের উপর দুটো এপিথেলিয়াম আছে, একটা বড় একটা ছোট, তোমার দেখে মনে হচ্ছে যে অ্যাজ ইফ যেন হচ্ছে যে এই সেলটা বোধহয় এর ওপরে আছে, হুইচ ইজ রং, ঠিক আছে, এবং তার সাথে সিলিয়া আছে। তো এইটাকে আমরা সিউডো স্ট্র্যাটিফিকেশন বলি, যেটা অ্যাকচুয়ালি নট এ ট্রু স্ট্র্যাটিফিকেশন, হুইচ ইজ অ্যাকচুয়ালি সিম্পল অ্যান্ড দ্যাট ইজ প্রেজেন্ট ইন আওয়ার রেসপিরেটরি epithelium, that is present in our trachea, that is present in our bronchus, that is present in our bronchiole. তো এটা খুব ইম্পর্টেন্ট কোয়েশ্চেন, সবাই একটু মাথায় রাখো। এটা জিজ্ঞেস করে যে হোয়াট ইজ দ্য নেম অফ দ্যাট epithelium. নেক্সট, ইউনিসেলুলার consisting of isolated glandular cell known as goblet cell of the alimentary canal and the multicellular consisting of cluster of cells that is present in the salivary gland, that is also true. NCERT তে পরিষ্কার ছবি রয়েছে, নিশ্চয়ই মনে আছে, গবলেট সেলের একটা পিকচার আছে NCERT তে, আর মাল্টিসেলুলার স্যালিভারি গ্ল্যান্ডসেরও কিন্তু পিকচার রয়েছে, যেটা আমাদেরকে খুব ভালো করে মাথায় রাখতে হবে। স্টেটমেন্ট নাম্বার 6 হচ্ছে, সেটাও কিন্তু ট্রু সেন্টেন্স। এটাও কি ছিল? এটাও ট্রু ছিল। 5 গ্ল্যান্ড সিক্রিট মিউকাস, স্যালাইভা, ইয়ারওয়াক্স, অয়েল, মিল্ক, ডাইজেস্টিক এনজাইম অ্যান্ড আদার প্রোডাক্ট, বাট নেভার এভার হরমোন। হরমোন যদি থাকে সেটা শুধু এক্সোক্রিন করবে, যদি ওখানে এক্সোক্রিন এন্ডোক্রিন বলা নেই, তো হরমোন বললেও আমি ঠিক করতাম এটা, কারণ এখানে গ্ল্যান্ডের মধ্যে কখনোই মেনশন করা নেই যে এন্ডোক্রিন না এক্সোক্রিন গ্ল্যান্ডের এখানে কথা হচ্ছে। সো স্টেটমেন্ট নাম্বার 7 দ্যাট ইজ অলসো কারেক্ট। অ্যাবসলিউটলি সবাই খুব ভালো উত্তর দিচ্ছে এখানে, পর্ণভ, অনুপম, Pradipta, everyone is correct. Let's go to the point, statement number 8. They cover the dry surface of the skin. আচ্ছা, স্কিনে কোন ধরনের এপিথেলিয়াম আছে? স্কিনকে নিশ্চয়ই অনেক ফ্রিকশন প্রিভেন্ট করতে হয়। সো অলওয়েজ রিমেম্বার, ইন দ্য স্কিন যেটা আমাদের থাকে সেটা হচ্ছে যে স্ট্র্যাটিফাইড কেরাটিনাইজড। একদম উপরে আমাদের একটা ডেড লেয়ার আছে প্রোটিনে, যাকে আমরা কেরাটিন বলি। সো কেরাটিনাইজ, স্ট্র্যাটিফাইড, কি ধরনের এপিথেলিয়াম? কি মনে হয়? স্কোয়ামাস। সো স্ট্র্যাটিফাইড স্কোয়ামাস কেরাটিনাইজড এপিথেলিয়াম, যেটা আমাদের স্কিনে রয়েছে। ওকে নেক্সট হচ্ছে, সো দে কভার দ্য ড্রাই সারফেস অফ দ্য স্কিন, ইনার লাইনিং অফ দ্য ডাক্ট অফ দ্য স্যালিভারি গ্ল্যান্ড অ্যান্ড দ্য প্যানক্রিয়াস। এবং নিশ্চয়ই বুঝতে পারছো, একটু আগে আমরা কথা বলেছি, ডাক্ট যদি হয়, আমাদের কোনো বডির ক্যাভিটি যদি হয়, সেখানে তো অনেক সময় সেখানে আমাদের মেকানিক্যাল স্ট্রেংথ অনেক দরকার ফ্রিকশন প্রিভেন্ট করার জন্য। তাই সেই সমস্ত জায়গাগুলোতে আমাদেরকে ভীষণভাবে মাথায় রাখতে হবে, সেইখানে কিন্তু স্ট্র্যাটিফাইড এপিথেলিয়াম থাকবে। ঠিক আছে, তো এটাও কারেক্ট। এখানে যদিও কিছু মেনশন করা নেই নন স্পেসিফিক্যালি, তাও এটাও কারেক্ট সেন্টেন্স রয়েছে। নেক্সট হচ্ছে, রিড দ্য সেন্টেন্স কেয়ারফুলি অ্যান্ড আবার আমাদেরকে বলতে হবে ট্রু নাকি ফলস। তো ফার্স্ট সেন্টেন্স আমাদের রয়েছে গ্যাপ জাংশন নিয়ে। গ্যাপ জাংশন facilitate the cells to communicate with each other by connecting the cytoplasm of the adjoining cells for rapid transfer of the ions, small molecules and sometimes big molecules. It is also true statement. স্টুডেন্টরা অনেক সময় এই সাইটোপ্লাজম কি করে কানেকশন হচ্ছে সেটা নিয়ে বলে যে স্যার এটাকে আপনি কেন কারেক্ট বলছেন, কিন্তু প্রথমত এটা এনসিইআরটি লাইন, আর দ্বিতীয়ত তার থেকে ইম্পর্টেন্ট হচ্ছে, দেখো এই যে ধরো গ্যাপ জাংশনের ডেফিনেশনটা কি, যে ধরো এইটা একটা সেলের মেমব্রেন, এই ধরো এটা হচ্ছে আর একটা সেলের মেমব্রেন, এবং এইটা হচ্ছে প্র্যাকটিক্যালি যে গ্যাপ, এটাকে বলা হয় গ্যাপ জাংশন। এরকম গ্যাপ জাংশন যে দুটো এপিথেলিয়ামের মধ্যে থাকবে শুধু সেটুকুই নয়, এরকম গ্যাপ জাংশন আমাদের ইনফ্যাক্ট হার্টের মধ্যে দুটো মায়োকার্ডিয়াল সেলসের মধ্যেও কিন্তু প্রেজেন্ট থাকে। আমাদের হার্টে যে দুটো মায়োকার্ডিয়াল সেলস, তার মধ্যেও কিন্তু এরকম গ্যাপ জাংশন প্রেজেন্ট থাকে। সো আই রিপিট অ্যান্ড আই রিকোয়েস্ট এভরিওয়ান টু রিমেম্বার যে এই যে গ্যাপ জাংশনটার কথা আমি বলছি, সেই গ্যাপ জাংশনটা যেন মাথায় থাকে যে এটা দুটো এপিথেলিয়ামের মধ্যে যেমন প্রেজেন্ট থাকে, তেমন হচ্ছে এটা কিন্তু মায়োকার্ডিয়ামের মধ্যেও প্রেজেন্ট আছে, এটা যেন মাথায় রাখে। এবং এই যে গ্যাপ জাংশন, এর কাজটা কি? একটা সেল থেকে আরেকটা সেলের মধ্যে ট্রান্সফারটাকে সহজ করে দেওয়া, কঠিন একদমই নয়। দেখা গেছে যে আমাদের হার্টের দুটো মাসল সেলের মধ্যে এরকম আছে বলেই একটা জিনিস, যে কোনো মলিকিউল যে স্পিডে যেতে পারতো তার থেকে 400 টাইমস বেশি ফাস্ট যেতে পারে। অ্যান্ড তাই জন্যই হার্টের প্রত্যেকটা মাসল একে অপরের সাথে অ্যাজ ইফ যেন কানেক্টেড আছে এরকম বিহেভ করে। তো এইটাকে বলা হয় গ্যাপ জাংশন। এখানে কি কি যায় আমরা অলরেডি দেখলাম। আচ্ছা, বাই দ্য ওয়ে, জাংশনটার হার্টের ক্ষেত্রে একটা নাম আছে জানো? এই গ্যাপ জাংশনটার হার্টের ক্ষেত্রে একটা নাম আছে যাকে বলা আইসিডি। আইসিডি মানে হোয়াট ইজ আইসিডি? কে বলতে পারবে হোয়াট ইজ আইসিডি? ভেরি গুড, ইন্টারক্যালিটেড ডিস্ক। অহনা সাহু বলেছে, ভেরি গুড, আই এম সো হ্যাপি। ইন্টারক্যালিটেড ডিস্ক, একদম ঠিক বলেছে, ইন্টারক্যালিটেড ডিস্ক, ভেরি গুড। সো দিস সেন্টেন্স ইজ কারেক্ট, বাট এটা কেউ যেন ভুল না করে যে কি করে সাইটোপ্লাজম কানেক্ট হচ্ছে। এটা কিন্তু এনসিইআরটি লাইন। এবং দ্বিতীয়ত তার থেকেও ইম্পর্টেন্ট হচ্ছে যে অ্যাজ ইফ যেহেতু একটা সেল থেকে আরেকটা সেলে তো খুব কুইকলি মলিকিউলটা ট্রান্সফার হচ্ছে, তো আমরা ধরে নিচ্ছি যে অ্যাজ ইফ ওটা একটা সাইটোপ্লাজমিক কানেকশন, যেন এটা সবার মাথায় থাকে। ভেরি গুড। নেক্সট হচ্ছে কানেকটিভ টিস্যু আর মোস্ট অ্যাবান্ডেন্ট ইন দ্য বডি। একদমই তাই, আমাদের দেহে সব থেকে বেশি যে টিস্যুটা আছে সেটা হচ্ছে কানেকটিভ টিস্যু, অ্যান্ড ওয়াইডলি ডিস্ট্রিবিউটেড ইন দ্য বডি অফ দ্য কমপ্লেক্স অ্যানিমাল। এবং আমরা জানি চারিদিকে ছড়িয়ে রয়েছে, দুটো অর্গানের মধ্যে সুন্দরভাবে কানেক্ট করছে কানেকটিভ টিস্যু। অ্যাবসলিউটলি কারেক্ট স্টেটমেন্ট নাম্বার 2 হচ্ছে কারেক্ট, 10 হচ্ছে কারেক্ট স্টেটমেন্ট। ভেরি গুড। নেক্সট স্টেটমেন্ট নাম্বার 11, দিস সেলস আর also secrete modified polysaccharide. It's a very very important question which behave actually এটা ধরো তোমার connective tissue হলে ধরো this is the cell of the connective tissue. These cells releasing some substances, and these substances are getting accumulated between these two cells, and these are made up of heteropolysaccharide plus some amount of the protein, and they are togetherly form matrix. এরাই ফর্ম করছে হচ্ছে ম্যাট্রিক্স। নট অনলি দ্যাট, দিস সেলস ইন কেস অফ কানেকটিভ টিস্যু, সাম অফ দিস সেলস known as fibroblast, they also releases fiber, and this fiber are also part of connective tissue. So please remember, they may release, if they are fibroblasts, some of them are actually fibroblasts, they release fibers like collagen and elastin, and some of them are actually forming the protein. Some of them are actually forming the protein. Some of them are secreting the heteropolysaccharide. So the sentence which accumulate between the cells and the fibers known as matrix. So এটাও কিন্তু correct, between the cells and between the fibers যেটা এরা ডিপোজিট করছে সেইটাকে আমরা ম্যাট্রিক্স বলি। এই বোঝা যাচ্ছে তো? সবাই বুঝতে পারছিস তো? এনার্জি আছে তো? সবার এনার্জি ফুল তো? একদম ফুল অফ এনার্জি তো সবাই? একদম ফুল অফ এনার্জি, হ্যাঁ কি না? নিটের আগে ফুল অফ এনার্জি তো? all right. Next হচ্ছে যে this excess of the nutrients which are not used immediately are converted into fat and stored in this tissue. কোন টিস্যু? তার মানে হচ্ছে ফ্যাটি টিস্যু, which is correct. ঠিক আছে, দেখো তোমরা নিশ্চয়ই জানো যে আমরা পড়েছিলাম, আমাদের এনসিইআরটি তে লেখা ছিল excess amount of the glucose are deposited in, মনে আছে GLUT4 দিয়ে কোথায় কোথায় ডিপোজিট হতো? এক হচ্ছে অ্যাডিপোসাইট সেল, আর নাম্বার 2 লিভার সেল। মনে আছে? অ্যাডিপোসাইট সেল আর লিভার সেল, এই দুটো জায়গাতে মনে আছে যে এক্সেস যে গ্লুকোজটা আছে সেটা ডিপোজিট হতো। All right, adipose tissue, correct. The collagen fiber are present in the rows between many parallel bundle of the fibers. তাহলে কোলাজেন ফাইবার যখন থাকে, তোমরা জানো ট্রিপল হেলিক্স প্যাটার্নে থাকে। It is not double helix, it is not a single helix protein, it is a triple helix protein, and they are with that's a very thick tough protein, সাদা white color protein, and they are present in parallel bundles. So this parallel bundle is a very good concept, very right concept for the collagen. But in case of elastin, please remember, it is neither triple helix and not parallel, rather they are present in such pattern of branching. So elastin is present in pattern of branching. আর একটা প্রোটিনও হয় যাকে আমরা রেটিকিউলিন বলি। রেটিকিউলিন ইজ নট ইন ইয়োর সিলেবাস, বাট দের ইজ অ্যানাদার প্রোটিন। সো এই তিনটেই প্রোটিন আমাদের টিস্যুতে থাকে, কানেকটিভ টিস্যুতে থাকে। আর কানেকটিভ টিস্যু মানেই হচ্ছে সেল, ম্যাট্রিক্স, ফাইবার, সেল, ম্যাট্রিক্স, ফাইবার, এই তিনটেই নিয়ে কানেকটিভ টিস্যুজ আমাদের তৈরি হয়। ভেরি গুড, যারা আনসার লিখছে আই রিয়েলি অ্যাপ্রিসিয়েট যে এত সুন্দরভাবে তোমরা জিনিসটা মনে করতে পারছো। আর এটা প্রত্যেকটা এনসিইআরটি লাইন, দ্য কোলাজেন ফাইবার্স আর প্রেজেন্ট ইন রোজ বিটুইন দ্য মেনি প্যারালাল বান্ডেলস অফ দ্য ফাইবার্স। কার্টিলেজ ইজ এ সলিড pliable and resist compression, এটা compressionকে resist করে, that is also true. Cartilage present in the tip of the nose, outer ear joint, between adjacent bones of the vertebral column, limb and hands of the adult. এইটা নিয়ে আমি একটু কথা বলবো, হাউ মেনি অ্যান্ড হোয়াট আর দ্য টাইপস অফ কার্টিলেজ। এটা কিন্তু কমন এক্সামে জিজ্ঞেস করে, সবাইকে মাথায় রাখতে হবে। কার্টিলেজ আমাদের যদি প্রশ্ন যখন এক্সামে আসে ম্যাচ দ্য কলাম জিজ্ঞেস করে কার্টিলেজে, তখন আমাদেরকে মাথায় রাখতে হবে 3 ধরনের কার্টিলেজ আমাদের এক্সামে আসে, এবং এটাই আমাদের সিলেবাসেও রয়েছে এনসিইআরটিতে। একটা হচ্ছে হায়ালিন কার্টিলেজ, নাম্বার 2 হচ্ছে ইলাস্টিক কার্টিলেজ, and number 3 যেটা রয়েছে the most important exam question, that is WFC. What is WFC? White fibro cartilage. So there are 3 types of cartilage. হায়ালিন কার্টিলেজ কোথায় থাকে? হায়ালিন কার্টিলেজ থাকে হচ্ছে, সবাই আমি ছবি আঁকবো, আজকে তো আমাদের রিভিশন ডে, আজকে আমরা এমন প্রসেসে পড়বো যেটা আমাদের কুইক মনে থাকবে। তাহলে আমরা দেখো আমার হায়ালিন কার্টিলেজ কোথায় আছে, দেখতে পাচ্ছ ট্রেকিয়ার যে রিংগুলো, এগুলো প্রত্যেকটা হায়ালিন কার্টিলেজে তৈরি। আর হায়ালিন কার্টিলেজ কোথায় আছে? এই যে দেখতে পাচ্ছ তোমার ল্যারিংসটা, সেই ল্যারিংসের মধ্যে তুমি জানো খুব ভালো করে যে টোটাল 9টা কার্টিলেজ আছে, তার এক একটা নাম রয়েছে। সেই 9টা কার্টিলেজের মধ্যে 8টা কার্টিলেজ, 8 out of 9 দে আর মেড আপ অফ হায়ালিন কার্টিলেজ। এই যে তোমার সুন্দর নাকটা, এই সুন্দর নাকে তুমি জানো খুব ভালো করে একটা ন্যাজাল সেপ্টাম বলে জিনিস আছে, ঠিক আছে? সেই ন্যাজাল সেপ্টামে কিছুটা হাড়ও আছে আর কিছুটা কার্টিলেজও আছে, বোনসও আছে, কার্টিলেজও আছে। দ্য কার্টিলেজ হুইচ ইজ প্রেজেন্ট ইন দ্য ন্যাজাল সেপ্টাম is also made up of hyaline cartilage. All right, and এই যে ধরো তোমার একটা হাড়, এই যে ধরো তোমার আর একটা হাড়, দুটো হাড়ের মধ্যে তুমি জানো there is something cartilage cap বলে একটা জিনিস আছে, সেটাও হচ্ছে হায়ালিন কার্টিলেজ। তাহলে হায়ালিন কার্টিলেজ কতগুলো জায়গাতে আছে, তাই না? ইলাস্টিক কার্টিলেজ কোথায় আছে? ইলাস্টিক কার্টিলেজ তোমার মনে আছে, এখানেই বললাম 8 out of 9 কার্টিলেজ, মানে আমার যে এই যে ল্যারিংস তার মধ্যে 9টার মধ্যে 8টা কার্টিলেজ হচ্ছে আমার হায়ালিন। বাট একটা কার্টিলেজ আছে যেটা ধরো এখানে এরকম সাপের ফনার মতো, তুমি যদি বড় করে মুখটা হাঁ করো, দেখবে জিভটা এরকম করে প্রেস করো, দেখবে নিচ থেকে এরকম একটা কিছু যেন মনে হচ্ছে বেরিয়ে আসছে, ওই যে কার্টিলেজটা, ঠিক আছে? এইটাকে বলে এপিগ্লটিস। এই এপিগ্লটিস গ্লটিসের ওপরে থাকে, এটা যদি আমাদের ধরো পুরো ল্যারিংসটা ভাবলাম, এর উপরে যে এই এপিগ্লটিসটা, এইটা হচ্ছে ইলাস্টিক কার্টিলেজ। কানটা, কানের এইটা না, এটা তো হচ্ছে তোমার সফট টিস্যু। এই যে কানের এই যে পার্টটা, এই জিনিসটাও কিন্তু হচ্ছে this is also, am I audible? Yes, this is also, you have to remember, that is all, this is also hyaline cartilage, ঠিক আছে? So don't say this is the hyaline cartilage, this is the hyaline cartilage, sorry, don't say this is the hyaline cartilage, this is the elastic cartilage, okay? So this is elastic cartilage, okay? All right, so this is, yes, pinna is the right answer. Pinna is the elastic cartilage and epiglottis is the elastic cartilage. And last but not the least, WFC, white fibrocartilaginous joint, most crucial questions, they actually form the cartilaginous joint. These joints, the joints where this amount of white fibrous tissue, actually there are, this cartilage is called white fibrocartilaginous tissue. Actually what happens in this cartilage tissue, you can see that rather than the cartilage cell, that is the chondroblast, chondrocyte, very huge amount of collagen are present over the matrix. Actually that's why this cartilage is very opaque. Light cannot pass through this cartilage because this is a very opaque cartilage. Lot of fibers. WFC has a lot of fibers. Now what is the location of WFC? WFC is located, this is my vertebra, this is my backbone. My backbone is composed of multiple small squared vertebra, you can see, and this vertebra in singular it is called vertebra, in plural it is called vertebrae. So these are vertebrae actually, and you know in between two successive vertebrae, there is a small intervertebral disc. This is called intervertebral disc, IVD. So just few minutes ago, we have read something called intercalated disc, ICD, which is actually gap junction represent kore. And this is something I am saying that IVD, that is intervertebral disc. This intervertebral disc is the example of WFC, white fibrocartilage. How you can remember? White fibrocartilage, they are present at the midline of the body. So intervertebral disc is something present at the midline. Not only that, if you see that this is the hip bone, this is another hip bone. So hope you can connect that this is the hip bone, this is another hip bone. Two hip bones are connecting in front. And there also a small narrow band of WFC present. This is called SP, symphysis pubis. So the symphysis pubis is also example of white fibrocartilage. Just before the exam today, we are doing the session. That's why I am very eager to draw the picture so you can remember in a more stronger way. So please remember, symphysis pubis, intervertebral disc, both are examples of white fibrocartilaginous joint, and they are known as cartilaginous joint. Guys, please remember, this kind of joint we can move, but up to a certain range. So this is called limited range of motion. And as it is limited range of motion joint, this is also called amphiarthrosis. Amphi matlab half, matlab thoda sa. So amphiarthrosis. Now, there is a very important question. What is called synarthrosis? So please remember what is called synarthrosis. Now I am drawing a skull. Hope you know that this is the skull, and in the skull bone, hope you know there is something called line can be seen in between two skull bones. So the line, this kind of line present between two skull bones are actually representing something which is called suture. This is called suture. Okay, this is called suture. This suture is actually joint. This is called sutural joint. The sutural joints are not cartilage. They are only collagen. They are only collagen, and such a huge collagen are actually sticking both of the skull bones, and that's why we cannot move. We cannot move the skull bones, and this is something called synarthrosis. This is something called synarthrosis. Absolutely correct. This is something called synarthrosis. All right. So very good. We have done the necessary revision. Next, again the same assertion and reason we will continue. Not assertion, reason, the statement. Sorry. Few more statements are remaining. The bone cells, osteocyte, are present in the spaces all called lacuna. Correct. In our bony cortex, first you have to remember, suppose this is the bone. So if you cross-sect the bone, if you cut the bone, you will see that this part is called the bone ka marrow. This is the bone ka marrow, which actually there is soft tissue present, like they will form the blood in future. So this is the bone marrow. This bone marrow is very soft. They will form the blood in future, red bone marrow. If it is replaced by the fat, it's called yellow bone marrow. Now forget about that. Now talk about the Haversian system. These are the multiple Haversian system you can see. Each of the Haversian system, at the center of the Haversian system, there is a canal called Haversian canal. This is called Haversian canal. Now this Haversian canal, around the Haversian canal, multiple concentric disc-like structures are present. Known as lamella. And in the lamella, if you scoop out some part of the lamellar matrix, it is also matrix, this is called bone matrix. If you scoop out some amount of the lamellar matrix, you are actually creating some gap area. This gap area known as lacuna. Lacuna matlab defect. And within this lacuna, you will get some cells. Some cells, especially three kind of cells can be present. One is called osteocyte, which is mature bone forming cell. Another is osteoblast, which is immature bone forming cell. And third is called osteoclast, which is actually the Rakshas cell, which is actually bone destroyer. Now, estrogen is someone who will suppress the clast. Je bhai tui theme thak, clast estrogen suppress the clast, and estrogen favors the blast, favors the site cell to mature further. So in a body of a female, suppose a lady who has completed the menstrual phase of life and now in the menopause, we know the common problem is the osteoporosis. Locomotion movement class 11. Suppose a female has completed the menopause and right now undergoing osteoporosis. What is the reason? The reason is that menopause, no ovarian tissue, some significant ovarian follicle left, no granulosa cell, no source of estrogen, less amount of the estrogen in the body, no one is there to suppress the clast. This Rakshas is having the huge now activity. All these clastic cells, now they are actually getting very much activated, and these clastic cells are destroying the lamella or matrix of the bone. Your bone matrix are getting destroyed. Now, what is the benefit of depositing calcium? I believe that you have enough blood supply and you are actually accumulating the calcium with the blood flow, because you know even in the bones blood flow will be there and this blood will be carrying the calcium. No problem in it. You carry the calcium. No problem. You carry the calcium. But you have already lost the matrix. So on what you will deposit this calcium? You have lost the polysaccharide matrix, protein matrix. This matrix is made up of protein and polysaccharide, and you have lost it by the overaction of the clast. So now what is the point of bringing calcium to it? So this is the funda behind osteoporosis. That's why if you give the calcium tablet to the lady of osteoporosis, you will not get that much benefit. Maximum what you can get, suppose there are some remaining matrix, you can just strengthen it by depositing much more calcium, but not more than it. All right, so this is the story of the osteoporosis and how the osteoclasts are getting overactivated in absence of the estrogen during the time of or after the time of menopause. All right, clear everyone? Clear? So okay, next sentence. The skeletal muscle fibers. So the last sentence from this chapter of NCERT, where we have to check that whether the sentence is correct or wrong. So please see this sentence. Skeletal muscle fibers are bundled together in parallel fashion. A sheath of tough connective tissue encloses the several bundle fibers. Correct. And that sheath is known as a fascia. And that the bundle of the multiple muscle cells are known as fascicle. So the bundle of the multiple muscle cells known as fascicle, the tough collagenous cover known as fascia. Right? Okay, so this sentence is also correct sentence. Now we will go to the next sentence of this chapter, and almost okay. So the cell junction hold them together and they are bundled together in a common connective sheath. in a common connective sheath. So the cell junction, this is something is important. Okay, most of the time I have seen the students are saying, sir, why you are saying the cell junction? Is there really any cell junction between this cylindrical skeletal muscle? So this is the cylindrical skeletal muscle. There is no, like, it is not myocardium that in between them is the gap junction. But still you can see that this sentence is saying that the cell junctions hold them together and they are bundled together by the connective tissue. Okay, is this true sentence or false sentence? Yes, actually this is true sentence. Okay, this sentence is true sentence and mainly true for myocardium. Cell junction fuse the plasma membrane of the cardiac muscle cell and make them stick together. Do you think this is true? Do you think this is true? Question number 39. Okay, you have to mention which sentence you are talking about. Are you talking about 18 or are you talking about 19? Are you talking about 18 or are you talking about 19? Sharnodeep, 18 you have said true. Yes, 18 is true. 19 is also true. Shubhajyoti saying 19 is true. What do you think? 19 is true or false? Arangshi Mollik is saying 19 true. Diditi is saying 19 true. Okay. Here Shrestha is saying 19 true. Noirit 19 true. So this 19 is very important. See, these are I have seen in multiple exams the students are making mistake with the sentence number 19, because 19th number sentence is saying cell junction fuse the plasma membrane. So the student has problem with the word fuse, because the moment we are mentioning fuse, the students are thinking that we are talking about the tight junction. But here the fuse word does not mean tight junction. Here even the fuse word is actually mentioning the gap junction. So I repeat and I recommend every student to mark this sentence number 9 and highlight it properly so that you won't make any mistake in actual exam. So the cell junction fuse the plasma membrane of the cardiac muscle cell. This fuse is not actually gap junction, not tight junction. This is actually still it is gap junction, and make them stick together. So it is true. Next, because this is NCERT sentence. First of all, this is NCERT sentence. Next, neuron, the unit of neuron, the unit of neural system are excitable. This is neuroglial cell actually. This is neuroglial cells which constitute the rest of the neural system, protect and support the neuron. That is also true. So neuron is the only excitable tissue, but neuroglia is not the excitable tissue. The neuroglia is not excitable. Neuroglia is just composing, and composing more than 50%. More than 50% of the nervous tissue is made up of neuroglia. Neuroglia make up more than half. Correct. More than half. In your nervous system, more than 50% is made up of the neuroglia. More than 50%. More than 50% is made up of the neuroglia. That is again true sentence, and you have to remember. Now it's a very simple difference that we have to revise. Tight junction versus gap junction versus adhering junction. Tight junction, remember the molecule, the membranes are very tightly attached. Don't say fuse, they are very tightly attached. Things cannot leak. Okay, things cannot leak. So no leak, L-E-A-K, no leak. A molecular ion cannot leak from one cell to the another cell if there is tight junction. The first thing is that no more things are required at your level. Gap junction, there is one cell, there is another cell, in between there is a gap. That's why it is called gap junction. I have already drawn. It is seen in the myocardium, also known as intercalated disc, as you know. Adhering junction, suppose this is a cell, this is another cell, and both of the cells, they are adhered with the help of some interconnecting protein as well, and they actually behave like a cementing. Just you remember this word cementing. They can be also cemented with the, suppose this is a cell, the cell can also be cemented with the basement membrane also sometime, but most often, very often you can see the cells, they are cementing with each other. Now the intercalated disc, you have to remember, it helps to pass on one molecule from this cell to another molecule very fast, that I have already mentioned, and it can be a small molecule, it can be ion, even it can be a large molecule. So very good. Next, types of connective tissue. So this classification is very important. Always remember, whenever you are saying the type of connective tissue, first you have to say, are you talking about the loose connective tissue or are you talking about the dense connective tissue? So that is the first classification. If you talk about the loose connective tissue, you can talk about the adipose connective tissue. If you talk about the loose connective tissue, you can talk about the areolar connective tissue. Okay, so areolar and adipose is only the loose connective tissue. If you talk about the dense connective tissue, there is simple classification. You have to say either regular dense or you have to say irregular dense. Whenever we are talking about the irregular dense connective tissue, we can mention about the skin. Whenever we are talking about the regular dense connective tissue, we can mention tendon, which is actually the connection between the muscle and bones. We can also mention ligament, which is connecting bones to bones. So please do remember this simple, very simple classification, and don't forget at the time of exam. This is areolar tissue. You remember this is areolar tissue. Areolar tissue is kind of khichdi. It's kind of khichdi. Lot of different types of cells are there in the areolar tissue, and you have to remember this areolar tissue is composed of what is not present in areolar tissue. Everything is present. Fibroblast present, plasma cell present in areolar tissue, histiocytes present, which is actually macrophagic cells. I mean it's phagocytic cells. So even blood vessels are present. So in the areolar tissue, many types of cell. I will simply write even adipocyte cells. So any type of cells are there in the areolar tissue. So many types of cell. I think the best examples, best descriptions for the areolar tissue, many types of cells are there. Okay, and please, I will write a word IBQ. I don't know how many students are aware of this fact that IBQ, I use this terminology. We have one book on behalf of PrepMed as well, image based question. If you follow the last 2-year NEET pattern, at least 2 to 3 questions are coming based on the NCERT images in black and white. So please, I would recommend every student to see the areolar image ka black and white from your NCERT book and find the every leveling, which one is plasma cell, which one is blood vessels, which one is histiocyte. Everything is pointed there already, and do practice it before NEET 2026. And adipose tissue, there is also IBQ. There is a probable chance to the nucleus of the IBQ is very interesting. Just remember, in case of adipose tissue, as you are depositing lot of triglyceride inside the cytoplasm of the adipose tissue, that will push the nucleus to one side, and you can see that as the nucleus is pushed to one side, so rest of the cytoplasm is filled with the fat, and it is giving a characteristic ring type of thing. This is called signet ring. So this is something called adipocyte cell. It's very important to identify the adipocyte cells. This is called adipocyte cell, the cell of the adipose tissue. So we have completed this. Now we are moving to the frog segment and the cockroach segment. In the animal tissue, it's very important. Most of the time I have seen students are very confused with the frogs and the cockroach. First, you remember their respiration, their digestion, their circulations, their excretions, their nervous system, their hormonal system. Each and everything are important. Each and everything is important. And we will revise. First of all, this picture. First, you have to remember the most common question I have seen, that is the something called thumb pad, which is unique for male frog. Thumb pad. The thumb pad is located in the forelimb and at the first finger. So please remember, there is a first finger, there is something called thumb pad. In the forelimb, there are 4 digits. In the hind limb, there are 5 digits. In the hind limb, you can see there is something called wave feet. In the hind limb, there is something called the wave feet through which they can easily swim. Now, forelimb, you know, first finger, that is called thumb pad, or it is also called copulatory pad. It is only for male. This is only for male. Which is this thing? This is the tympanum. Tympanum. What is tympanum? Our eardrum. Tympanum matlab iske bahar mein hota hai. That is something called external ear. For them, they don't have external ear. They are directly having the tympanum, and they can feel the vibration. Someone is walking and they can feel the vibration with this. In their eye, there is something called a special, eyelid. Upper eyelid, lower eyelid is also present, and there is something called eyelid. That is something called nictitating membrane. Nictitating membrane. There is something called nictitating membrane. This nictitating membrane is the third eyelid. We also have the remnant of the nictitating membrane at the corner of our medial corner of our eye. So these are the main questions. And next, we have to remember the skin are very sensitive. There's a question in the biodiversity that if there is pollution, who is going to be suffered most? It's amphibia, because through their skin they also do the respiration. They do the respiration. It's very important when they are under the water. Please do remember, this is an NCERT question and very important NEET question. If they are moving to the water, they will respire with the help of skin only. So when they are present under the water, they will respire with the help of the skin only. Now, talking about their respirations, if they are jumping, at that point of time, they do something that's called positive pressure respiration. What is that? When they're jumping, they are engulfing some amount of the air inside their mouth. And in their mouth, pharynx, in their pharyngeal cavity, they have some capillary-like things, just like our lung alveoli. And with this positive pressure, they are pushing the oxygen into the blood capillary. That's why that is called, here they are actually performing positive pressure respiration. So their respiration techniques are very important. This respiration technique is called buccopharyngeal respiration. Buccopharyngeal respiration, very important for NEET purpose. What is buccopharyngeal respiration? What is buccopharyngeal respiration is very important. So one is the buccopharyngeal respiration that we have covered. You already know that there are lungs. You can see this lung, pink color lungs are already there. These lungs are also, this lung is will follow the negative respiration, just like us. We also follow the negative respiration. Alveoli will be in the negative pressures, and the air will be already sucked in. That is a pulmonary respiration. So how many types of respiration are there? Number one, pulmonary respiration, buccopharyngeal respiration, and this is called cutaneous respiration. Skin, cutaneous respiration. This is something called cutaneous respiration. So please remember, cutaneous respiration, buccopharyngeal respiration, and pulmonary respirations. These are the major types of the respiration the frog can perform, and very, very important for NEET 2026. So aquatic, when they are under the water, they will do only the aquatic, they will do the cutaneous respiration. Okay, when they are jumping, they will follow the buccopharyngeal respiration, which is positive respiration. Okay, positive respiration. They will create the positive pressure to push the air. But the mechanism of the lung, we have to create the negative pressure. They have to create the negative pressure in the lung to suck the air inside it. All right. So these are very important concepts. Please do remember. Now the question, this is a very, 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 very important thing. What is cloaca? The cloaca is very important. So I would recommend everyone to remember that what is the cloaca. Please mark this area is the cloaca. Please mark this area is the cloaca. Cloaca is a very important. Why the cloaca is important? Because cloaca is the common chamber. You can see in the cloaca stools are coming. This is fan-like thing is actually urinary bladder. Okay, this is the urinary bladder. So the urine is also coming. So you can see urines are coming. You can see stools are coming, and they are mixed up in the cloaca. So in the cloaca, this is mixed up. All right. Can you say, is this male or female frog? No, it is not possible, because we haven't drawn neither testis, we haven't drawn nor the ovary. So this is we cannot say the sex of this frog. What we can say, that cloaca present or not. This is the cloaca. Absolutely the cloaca will be present. Okay. So cloaca is the feature. What is this fat body? Guys, please remember, fat body for cockroach and fat body for frog having different role. Fat body for cockroach, fat body for the cockroach, they help lot in the excretion system, excretory purpose. Uricose gland, fat bodies, these are for cockroach, remember, helps in the excretion. But for the frog, fat bodies is a source of the energy, source of the energy, it is a source of the energy, it is a source of the energy during aestivation, hibernation. So during aestivation and hibernation. Aestivation, I hope you know, aestivation is the winter sleep, and aestivation is the summer sleep, and hibernation is the winter sleep. Am I clear to everyone? Am I clear to everyone? Okay, all right. So now, is there any diaphragm? It is amphibia, so no diaphragm. You can simply see the this is the liver, and on the liver you can see the gallbladder, and just behind the liver you can see the lung. So no diaphragm. So please cross and write there is no diaphragm. There is no diaphragm. Please write, because diaphragm feature starts from diaphragm starts from class Mammalia, but this is the class Amphibia. Okay, so feature diaphragm starts from class Mammalia. Okay, all right. So we discussed about the cloaca already. Please don't forget, there is a high chance that this year this cloaca will be given as image based question, and I'm writing N26, or some point of my discussion I will write N26, and N26 means this year it's a highly probable questions for conceptual purpose or directly pointed out as IBQ, image based question. So next I am moving to the two frog. Usually I have seen students are making mistake with such images. See, it's a best way to revise before the exam, to revise all the pictures and revise the concepts that we are exactly doing. So this is the male frog, this is the female frog. The male frog is identified with the help of the testes. You can see the testes. Now the question is that this is something, the parallel line you can see, these parallel lines are known as vasa efferentia. These parallel lines, guys, these parallel lines are known as vasa efferentia. Here also you can see the vasa efferentia. Now the sperm of the frog is produced in the testes, right? The sperm of the frog is produced in testes. All right. Now what will be the pathway of the sperm to get out of the body? So I mean, now our purpose, somehow the sperm has to be exterior of the body. See, the sperm is produced here, and you want the sperm out of the body inside the water, because you know they will not ejaculate inside the body of the female, because they will follow external fertilization. So please write, as they will follow the external fertilization. So external fertilization, they will follow the external fertilization. Now we have to remember what is the pathway of this sperm. First, it's very important, everyone do write. First, the sperm will be produced in the testes. Then the sperm will be passing, as you can see, in the vasa efferentia. I am writing simply vasa efferentia. Then it will reach to the kidney matrix, I mean the kidney tissue. So this kidney word is very important here. Then in the kidney, they will form something called Beeder's canal. And the Beeder's canal will join, all the Beeder's canal will join, and they will join with the main ureter. So then we will write something called ureter, and from that point the ureter will be known as UGD, that is a urinogenital duct. It's not containing urine, but also you are pouring their sperm, so there will be mixture. So urinogenital duct, and urinogenital duct, you can see this urinogenital duct, actually here you can see urinogenital duct. This is the urinogenital duct, you can see this is the urinogenital duct right side, this is the urinogenital duct of the left side, and then they are coming to that common chamber which is just after the rectum, After the rectum, stool is coming, this urine is coming, semen is coming, known as cloaca. So write down the final thing is the cloaca. So hope you understood. Hope you understood the pathway of the semen. This is a very important question, PYQ as well. Cloaca. So what is the cloaca? Cloaca. So remember this cloaca. Okay. So testis, vasa efferentia, kidney, Bidder's canal, UGD, and cloaca. So this is the pathway of the spermatozoa in the body of the male frog. Now what is this gland? This anteriorly long gland, usually in our body, it is present above the kidney, known as adrenal gland. For them, adrenal gland is present in front of the kidney. So it is important, very, very important. Now talking about the female one. Acha, by the way, you have to remember, you already know the fat body which is present on the above the kidney or in front of the kidney, whatever you say, and they mainly store the fat which will be used, which they will use during the time of estivation and during the time of hibernation. All right. Okay, next one again very important. Next one, that is how this testis and the kidney will be connected. How this testis and the kidney will be connected. So please remember the testis, the testis and the kidney. The testis and the kidney that will be connected. The testis and the kidney that will be connected with mesorchium. That will be connected with mesorchium, mesorchium, M-E-S-O-R, mesorchium or mesorchium. Okay, now this part, the female part. In the female part, this is the ovary, with not that exactly oval shape like in testis. This is the female ovary. The female ovary is again covered by some layer, is called mesovarium. This is called mesovarium, the mesovarium. This mesovarium are produced, they produce the egg cell that will be captured by the oviduct of both the side. Once they are captured, you can see that in the cloaca they would be also joining. So oviduct, it's completely another duct that is also joining. So if anyone is asking what are the number of duct in case of the female joining to the cloaca, your answer will be one more. That is oviduct. So oviduct is one duct joining to the cloaca. Next is, you already know, this is the ureter, because for the female, please don't say, because in the option there will be urinogenital duct, but for the female there is no urinogenital duct. So please remember, for female it is ureter which is opening to the cloaca. For male it is the urinogenital duct which is opening to the cloaca. So if anyone is asking what are the structures that are opening inside, in case of the female inside the cloaca, you just mention two oviduct and two ureter. Don't mention two oviduct, two urinogenital duct. Two oviduct and two ureter, not urinogenital. It's ureter only. Now the same thing, the egg will be passed outside the body, and there will be external fertilization, formations of the zygote. From there you will get the tadpole larva. Tadpole larva in animal kingdom we get in two cases. One in case of amphibia, another also remember in case of urochordate. In case of urochordate also we do mention something called tadpole larva. All right, okay. Now this is something about the cockroach. So what are the relevant MCQs for the cockroach? First you have to remember there are a lot of MCQs. We will recall each and every MCQs with this picture only. All right. So first of all you have to remember these are called antenna. So antenna of cockroach. How many antennas are cockroach? There are a pair of antenna. Only two antennas are present in case of cockroach. Okay. Now if we talk about in case of crustaceans, please remember guys, please remember, suppose this is one prawn, and you will see that there are there are two long and two short antenna. There are two long and two short antenna. So don't get confused with the crustacean antenna and also the insect antenna. So the antenna may also be variable. So please do remember. So first of all, we have completed that antenna concept. Now the point where the antenna is landing, there you can see the eyes of the cockroach. Now what are the MCQs of the eyes of the cockroach? Please remember, the eyes of the cockroach, they consist of multiple small eye. Each of the eye is actually small eye forming multiple images, and almost 2000 hexagonal small eyes, they are forming something called ommatidia. This something called ommatidia. And each of the ommatidia is consist of 2000 ommatidium. Each ommatidium, they will form an image. That another ommatidium will form another image, another ommatidium for another image, and all the images, they are falling one after another, and this are making their image formation very blurred image. That's why the resolution of their eye is very poor, but the sensitivity of the eye, even a small, very small intense light, they can easily sense. So that is very important for the ommatidium. Ommatidium is called compound eye, and there is something called simple eye, which is just behind this ommatidium. These are called the simple eyes as well. So in cockroach, compound eye and simple eye both are present. Now you can see something called pronotum. What is pronotum? The pronotum is actually it's actually a segment just behind the head, and it is covering the prothorax as well. So you know, in case of cockroach, this is the head, and rest of and there is called prothorax, mesothorax and metathorax, and there is abdomen. So the prothorax and the head, there is a joining segment, that is something called pronotum. That's called pronotum. Next mesothorax. First you have to see how many wings are there. Wings are two pair. So this is the first pair, and you can see second pair. So two pair of wings are present. The bigger wings you can see, the broader wings, the darker wings, the heavier wings, the leathery wings, the thicker wings, known as tegmina. And as they are broader, they are darker, they are thicker, they will not help in fly. They are just protector. They are just protector of the subsequent hind wings. So the fore wings are the protector. The fore wings are the protector of the hind wings only. They will not help in flying. The flying will be done by the hind wing only. That will only help in flying. Remember guys, this tegmina is very important, and they are protector only. Tegmina do not help in flying, but still it has name like tegmina. Elytra, E-L-Y-T-R-A. So though it is not helping in any flying mechanism, but still it has many alternative name like tegmina and elytra. And hind wing really helping in flying, but it has no name. Now the question is that we know that forewing. Okay, I am just drawing a small picture, quick picture, and you also draw with me. This is the model picture of the cockroach ka body. So hope you got the idea. This is the head, this is the thorax ka teen segment, prothorax, mesothorax and metathorax. Now focus to this three thoracic segment. What I am doing that mesothorax, they are forming the bigger wings, that is called tegmina and elytra, just we have read. And the metathorax, guys, please remember, they are forming the smaller wing. They are forming the smaller wing. So the prothorax, just draw a big question mark because there is no wing. That is something I just want to portray. I just want to portray to all of you that the prothorax, they are not forming any wing. The meso and the metathorax, they are giving the wing only. Now you remember, if I talk about the leg, you remember the leg. See, this is the leg. The leg is forming all three thoracic segment. The prothoracic segment, mesothoracic segment and metathoracic segment, all three segment, the legs are there. Now the angle of the head and the prothorax, it is 90 degree, as you can see. So these are the main questions that I wanted to highlight, and I have already highlighted. Now you know abdominal segment. How many abdominal segments are there? You know there are total 10 abdominal segments are there. There are total 10 abdominal segments are there. If I talk about their abdomen, where is the heart? Where is the nervous system? Just opposite to our body. In our body, you know the nervous system is presented at the back side or dorsal side. But for them, the nervous system is present in the ventral side. In our body, the nervous system is present single. But for their body, the nervous system are present in pair cord. They are present in pair cord. Okay, in our body, the nervous system are the nerve cord which is hollow, but for their body as it is invertebrate, it is solid. So it is 2 in number, 2, you can see 2 cords I have drawn, and it is solid. Now how many ganglia is present? There is a common saying that if we cut the head of the cockroach, it will still survive for next 7 days. It is written in NCERT, and it's very important. Why they will survive for next 7 days without their brain? Because the most of the nervous tissue in their body present in format of the ganglion, and students are writing. I'm very happy that everyone are able to recall here. Okay, so the ganglion are present. Ganglion are present here. So ganglion are present here. Here you can see. Let me draw the ventral side. You can see the ganglion. The ganglions are present here. Okay, the ganglions are present here. You can see the ganglions are present here. Total number of ganglions present here in abdominal segment 6 ganglion, and thoracic segment, in each thoracic segment 3 ganglion. So total, remember, 9 ganglion. 9 ganglions are present at the ventral aspect of the body of the cockroach, and 1 or 2 ganglions are also present here, that is called supraesophageal region. Okay, there are also some ganglions. So very little amount of the nervous tissue is present in their brain. That's why if you cut their brain, they can even survive for 7 days without their brain. But still, why not more than 7 days? Because after the 7 days, they will not able to eat, because eating is also important. If you are not taking digestion, if you are not taking the food, how they will survive? Please remember that there are the antenna. The antenna help the sensation, the feeling that where they are going, and they have some, you know, this is something called pulp. I hope you know maxillary pulp. Okay, there is something called labial pulp. This pulp is actually helping them in taste. So they will not be able to feel anything with the help of the antenna, because the antenna is getting the nerve supply from the supraesophageal ganglion. So they will not be, you know, they will not be able to touch anything or feel the nearby sensation. They cannot, they don't know where to go. Not only that, there are, you know, eyes. There are eyes. I know compound eyes, ommatidium, but still they have eyes and they can feel it. That sensation even passes to the supraesophageal ganglion. So as you have cut the head, supraesophageal sensation also lost. Supraesophageal sensation, ganglion sensation. This ganglion is located just above their esophagus. That's why this ganglion is called supraesophageal ganglion. So please remember, if you cut the head, you are actually cutting the supraesophageal ganglion. They will not be able to sense with the help of antenna. They will not able to visualize anything with the help of this compound eye. And not only that, they will not able to be, they will not be able to eat anything, because you have cut because the sensation from this maxillary pulp and the labial pulp, that also passes to the supraesophageal ganglion. So please remember, these are very crucial concept. So if you even but up to 7 days they can survive, because all these ganglions are not present in the brain, not in head. These are present in thorax and all over the body, all over the abdomen. So hope you understood and hope you have enjoyed this segment. This was very important. Now they're talking about how to identify the male cockroach versus female cockroach, common MCQ. See, there are three ways. Number one, anal cerci present in both, ठीक है, anal cerci present in both, which is present on the 10th abdominal segment. So don't talk about the anal cerci please, because it is present in both. We have to talk about the 9 segment ka thing, and that is called anal style or caudal style. So this anal style which is present on the 9th segment, 9th of the male only, that is differentiating, that can be differentiating of male from a female, number 1. Number 2, you have to remember, for male, this wing, the elytra, that will cover more than the body length, okay? And not only that, we have to also see some segments. The segments, like if you mark the abdominal segment like 1, 2, 3, 4, 5 and 6 and 7 and 8 and 9 and 10, you can see in case of female cockroach, the 7th, 8th and 9th ka ventral is having some different kind of shape. They are ventral segments. Especially the 7th is the boat shaped segment, and they are fusing with the 8th ventral segment and 9th ventral segment. Can you tell me how their body is covered? The body of the cockroach from the dorsal aspect is covered by something which is that is called targite, okay? And ventrally it is covered sternite. Both are examples of sclerite. Both are example of the sclerite. So please remember, the sclerites are 2 types: ventrally sternite, dorsally targite. Here the 7th, 8th, 9th tarjam are forming, and they are different type of shape in case of the female, and 7th is specially forming the boat. They are forming, so this fusion of the 7th, 8th, 9th sternite is seen in the female. All right. And how to identify the male? In case of the male, remember the 9th, 10th and 9th, 10th dorsum and 8th entire segment. 9th, 10th dorsum, 9th, 10th dorsum and 8th entire segment, they are actually fusing and forming something which is unique in the body of the male. So this is also will help us to identify the male versus female. Yes, for male, 9th and 10th tarja. Yes, for male, 9th and 10th tarja and 9th sterna. Yes, correct. Not 8th. Yes, correct. No need to include the 8th. You just mention 9th and 10th ka tarja and 9th ka sterna also. So 9th ka complete and 10th ka only tarja. Okay, so they will form something called, this is only for the male cockroach. Okay, this is for the male cockroach. So male will protect the side. Okay, what are protected here? The females, with the help of 7, 8 and 9, they are protecting their external genitalia. The male, with the help of this 9th and 9th entire 9th, because dorsal ventral both are covered, and 10th also, they are also covering the genitalia. Now the genitalia, I know it's a bit difficult for you, but before that, genitalia, I know for many students it is pain point, genitalia, but still cockroach ka genitalia I will explain. But before that, you remember all this picture, please. In exam, you will be asked to mark the mandible, you will be asked to mark the labrum, you will be asked to mark the labium. So please remember all these things. This is, this is the labial, here it is maxillary pulp. I am shading it red. This is the maxillary pulp. Okay, this is the maxillary pulp and this is the maxilla bone. Okay, now in yellow I am marking the labial pulp. Okay, labia is the lower lip. This is the labial pulp I have marked, and you have to identify each of that: labrum, labium, mandible, hypopharynx and maxilla. Maxilla, this is the maxillary pulp. Labia, this is the labial pulp. I have already told you different parts of the cockroach ka body. okay, of head. Now, how many alary muscles are there? How many alary muscles are there? Remember, heart chambers are 13. For cockroach, the chamber of the hearts are 13. There are 13 chambers. There are total 13 chambers. And remember, within each chambers, you can see the chambers. The chambers are funnel-like, right? This is the funnel-like. See, this is like this, like this, like this. So each chamber is funnel-like, and the alary muscle is present at the junction of a subsequent two chambers. Subsequent two chambers. So alary muscles are present in subsequent two chambers. Alary muscles are present in subsequent two chambers. Alary muscles are present in subsequent two chambers. Please remember, alary muscles are present in subsequent two chambers. So 13 chambers. So gap, common area 12. So that's why alary muscles are 12 pairs. So don't forget, please. So that's why alary muscles are 12 pairs. 12 pairs of alary muscles are there. Now this is anterior body end, this is a posterior body end. Please remember that how the blood enters in the body, it's very important. How the blood enters in the body, it's very important. So I just want to draw that the simplified picture, that let's say this is the body of the cockroach, and let's say this is the heart and heart like this. So please remember, this area is, let's say, the hemocoel. This area is the hemocoel, where the blood and the hemocyte cells are there. And in this blood there is something called trehalose. There is something called oligosaccharide called trehalose is also present. This is a question. Sometime I have seen some teachers are asking trehalose. And always remember that the blood is from the hemocoel, they are entering from the posterior heart chambers, then passing from each and every ostia. Now the question is, how many ostias are there? Even some teachers are asking how many ostias are there. See, in each chamber you can see this is one ostia, this is another ostia. For the second chamber also there is a small ostia opening and the large ostia. So each heart chamber is having one pair of ostia. And finally you remember, total number of ostia is 13 pairs. 13 pairs of ostia. So please remember these MCQs: 13 pairs ostia, 12 pairs alary muscle, and 13 heart chambers. These are important question. Now, and the blood, how it is flowing? It is from the hemocoel, passing into the posterior chamber of the heart, then passing to the anterior chamber of the heart, and then again from the anterior chamber to the hemocoel. Why this hemocoel why the blood is opening here? Why this is called open circulation? This is called open circulation. This is called open circulation because the whatever the organ, suppose this is the organ, suppose the digestive tract or whatever the organ, reproductive organs, whatever the organs present in the hemocoel, they will be smeared with the blood. They are actually flooded with the blood. You can see the blood is directly bathing them. So that's why this is called open circulation. That's why it is called open circulation. Am I clear to everyone? Am I clear to everyone? Very good, very good, very good. Now talking about the digestive system of the cockroach. Very important. The digestive system of the cockroach is known as foregut, midgut, and hindgut. How to differentiate foregut and midgut? With the help of the hepatic ceca. If you see this hepatic ceca, which are actually having like this kind of structure, this is called the hepatic ceca. You can see hepatic ceca, it's actually close-ended, one side closed. This is called hepatic ceca. They are present 6 to 8 in numbers. They are behaving like the liver. They are present in between the crop and the midgut, and this is called the hepatic ceca. 6 to 8 in number. Now, what is Malpighian tubule? Malpighian tubules is present in between the midgut and the hindgut, but they are not as thick as like hepatic ceca. They are very thin tubule-like of thick, and they are present many. They are present 100 to 150 Malpighian tubules empty are present. Malpighian tubules. What Malpighian tubule does? I have already mentioned that is each of this organ, they are bathing into the blood, and you know, in the blood of the cockroach, the main excretory nitrogenous material is the uric acid, and that uric acid will be captured by this Malpighian tubule. This uric acid will be captured by this 100 to 150 Malpighian tubule, and that uric acid is dropped into this gut, that hind gut, and ultimately this uric acid is passing through the rectum of the cockroach. So am I clear that how the excretory material is collected and how and what is the excretory material? Please remember, it is the uric acid. It is the question of the excretory system. Usually that is written in NCERT in excretory system of human, but you have to remember the uric acid is the insect ka excretory material that you have to remember. So foregut you know, midgut you know, hindgut you know. Okay, now talking about the crop. Is there any MCQ in crop? Is there any MCQ in the crop? No, no such MCQ. Just to remember the food is getting stored. But there are a lot of MCQ in the gizzard. What is the gizzard? Gizzard is the area where you can see that 6 chitin made plate. 6, like you know, mixie. We use mixie at home where there are blades. The blades are actually cutting the foods. Here's the same way you have to remember. In the same way, you have to, very good. Some people are writing continuously, and I'm very, very happy that they are able to recall the relevant segment. So you remember there are 6 chitinous plate. There are 6 chitinous plate. The 6 chitinous plate in the gizzard, they are behaving like the mixie. Okay, and this gizzard, there is an alternative name of the gizzard is also important. That's called proventricularis. Proventricularis. This is called proventricularis, and there is a very unique organ for cockroach that's called salivary reservoir. Cockroach is not only having the salivary gland, they're also having the salivary reservoir. So they will also store the saliva. Okay, it's not like our body that we are releasing the saliva and with the help of the duct the entire saliva will be in mouth. But for cockroach, you know, there is something, the concept called salivary reservoir, which is very unique. And please remember, I have already mentioned this part of the cockroach, of the first part of the digestive tract of the cockroach is known as esophagus. I have already mentioned, and just above it, nearby to it, there is one cluster of neuron known as supraesophageal ganglion of cockroach that I have already mentioned. So hope you can connect, right? Okay, all right. So these are the different questions you have to remember. The midgut, this is called mesenteron or midgut. So sometime I have seen the teachers are giving you the word mesenteron in place of midgut. So don't get confused what is mesenteron. So what are the what is the sequence? Please remember, it's a very important question. Esophagus is this one. Okay. So for the last time I am highlighting this is the esophagus. Okay. This bulgy area is the crop. This is the, you know, gizzard. Okay, this is the mesenteron. Okay, this is the mesenteron. This small part is the ileum, and then the large part is the colon, and the last part is the rectum. So guys, are you happy with this? Are you happy with this sequence? This sequence is very, 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 very important. So the teacher will ask you immediately after the Malpighian tubule, what is the part? Please remember ileum. And that is very special for today's session. This ileum, I am telling multiple times. I have seen the students are making mistake. They are not able to mark that. If anyone is asking that immediately after the Malpighian tubule, what is the name of the part? Students are marking colon. No, it is not colon. Immediately after the ileum, immediately after the Malpighian tubule, the part you have to mark is ileum. Immediately after the hepatic ceca, the part that you have to mark, that is everyone that can mark, that is something called the midgut. All right, and immediately before the hepatic ceca, the part is gizzard. So students are mainly making mistake here. The three parts. What are the 3 parts of the hindgut? Ileum, then colon, then rectum. Repeat with me. Ileum, colon and rectum are the parts of hindgut. So please remember the number 1 ileum, number 2 colon, and number 3 rectum. Am I clear to everyone? Am I clear to everyone? Yes, 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 yes. It's a very good practice that you are writing and you are trying to recall. It's a very important thing. You are writing and you are trying to recall. It's a very important thing. So ileum, colon, rectum. Ileum, colon, rectum, they are the parts of the hindgut. So I have already covered the circulatory, open circulatory system of the cockroach, how the hemolymph from the hemocoel passing through the posterior chamber, coming to the anterior again and entering into the hemocoel, and how they are bathing the entire organ. Now the most difficult area, and it's a pain point of every student that you are not able to recall. So now today I am saying you the very quick and easy trick how you can remember. So these are the testes. This is the male testis ka right testis, and this is the left testis. The testis ka expansion, I mean the extension, is present from the segment number 4 to segment number 6. No, sorry, segment number 2 to segment number 4 is from the segment number 2 to segment number 4. But here you can see the extension is a bit more, and you can see from the even from the segment number 2 up to the segment number 6, you can see the ovaries are extending. So ovaries are extending from segment number 2 to 6. Testes are extending from 2 to 4 only. Testes are extending from 2 to 4 only. For 2 to 4 only. Yes, for up to 2 to 4 only. Okay, now you have to remember that both of the testes, okay, 4 to 6, Shrestha is saying that 4 to 6 in testes. Okay, 4 to 6 in testes. Swarnadeep is saying 4 to 6 is testes. Okay. So this is 4 to 6. Yes, right. I also think the same. This is the 4 to 6 in testes. Somehow I have written it the wrong way. So this is 4 to 6. This is a 4 to 6 and this is 2 to 6. Correct. You guys are correct. This is 2 to 6. This is 4 to 6. Now, important concept is that there is no concept of tube like in case of human. Even in case of frog, there are some tube concept in the testes. Okay, in case of cockroach, there is no such tube concept in male, but in female there are tube concept, and you can see the tubes, like these are tubes. How many tubes? 8 tubes in each ovary. This ovary is made up of 8 tubes, and that ovary is also made up of 8 tubes. These tubes are known as ovariole or ovarian tube. These tubes are known as ovariole or ovarian tube. Alright, now total there is right ovariole, 8 ovariole. This is 8 left ovariole. The ovarioles are forming right ovary and left ovary. Here the testes are forming, no such tube concept, only right testis, left testis up to the 6th segment. Okay, now from the testis you can see these ducts are coming, known as vas deferens. You can see these ducts are coming, these ducts are known as vas deferens. Okay, here also from the ovary you can see these ducts are coming, these are called oviduct. These ducts are coming, these ducts are called oviduct. These ducts are coming, these ducts are called oviduct. Now you have to remember that this small flower-like thing in case of the male, and the location you can imagine is at the level of the 6th. You can see at the level of the 6th. These are called seminal vesicles. This entire flower-like things are actually seminal vesicles. In the center of this flower, you can see small tubule of the seminal vesicle, and here you can see large tubule of the seminal vesicle. So the entire thing is actually known as seminal vesicle. And just above the seminal vesicle, you can clearly see there is something called phallic gland. There is something called phallic gland. Just above it, there is something called phallic gland. Just above the seminal vesicle, there is something called the phallic gland. All right. Now, in our body also, you know there is something called ejaculatory duct. Can you remember this equation? ED is equal to, in our body, in case of in the class 12 we have read that ejaculatory duct is actually vas deferens plus Vas difference plus seminal vesicle. Can you remember this equation? Ejaculatory duct will be fusing with the vas difference and the ampulla of seminal vesicle. Here also you can see that seminal vesicles are fusing with the vas difference and they are forming two ejaculatory duct. I am drawing in green. These are two ejaculatory duct. Hope you can mark it. Two ejaculatory duct. This ejaculatory duct are directly opening into the structure. Okay, into a structure. This structure you can say this is called gonopophysis. You can say gonopophysis, and some people also say genital chamber and all these things. But actually, this is directly opening outside the body. And there are some external genitalia like things, like in human male also penis is there. Here is also some external genitalia like right phallomere, left ventral phallomere, right phallomere, and that's called ventral phallomere. These are the external genitalia. Not only that, right phallomere, left phallomere, and ventral phallomere. So how many phallomeres, how many types of phallomere are there? Right phallomere, left phallomere, ventral phallomere. Not only that, there is something called TT letter, another example of the external genitalia, and there is something called pseudo penis as well. There is something called pseudo penis as well. You know, there is something called anal cerci. Acha, what is the function of the anal cerci? Very, very important PYQ. Anal cerci does not help in any kind of sex identification. Anal cerci is present in both male and female and help in the sensation of the touch. It helps in the sensation of the touch. That's why it is very essential that has to be present in both male and female. So it has to be present in both male and female because it is the main function of the anal cerci, which is present on the 10th abdominal segment. The function is the touch only. Now talking about the caudal style, that is unique. That is also helping in the touch and all this thing, but that is unique in the male. So caudal style present on the 9th segment, unique for male, but anal cerci very, very important. Every NEET examinations I have seen that the teacher is multiple time checking the concept, multiple time testing you guys that whether you are aware of that anal cerci present in both, because the function in both the male and the female of the anal cerci is the same, that the touch sensation and any sensation kind of thing that is perceived by the anal cerci, or which is present on the 10th abdominal segment. But anal style, caudal style present on the 9th segment, that function is also sensation, but it is available for the male only on the 9th segment, and anal cerci 10. So I have written 10 beside the anal cerci and caudal style 9th. Now for the female, what you can see here, both of the oviduct, they are fusing, they are forming, this is called common oviduct. They are forming, this is called the common oviduct, or this is also known as vagina. This pink color thing, you will not be able to see anything uterus here. The common oviduct, they are forming directly, the part is known as the vagina. Now the vagina or the common oviduct, they will be opening into a chamber, and that entire chamber, this entire chamber of the female cockroach, the entire chamber of the female cockroach is known as GP. GP matlab genital pouch. The genital pouch will hold the opening of three things. Three things will be opening there. In the genital pouch, three things will be opening. You can see a tree-like glands. You can see tree-like glands known as collateral glands in the right side, also opening into the, opening into this GP, opening into the GP genital pouch. This is opening, okay. This tree-like gland. Remember, this is the opening. Below the opening, that is called vestibule. Above the opening, that is called genital chamber. So this tree-like gland known as collateral gland, they actually secrete the just immediately after that I'm going to explain you in case of the, there is something called, in case of female cockroach, that's called ukaineti formations, okay? And there and actually that there is a covering. That covering is actually secreted by this collateral gland. So the collateral glands are actually giving the covering of each and every kinety. Okay. All right. In female ovarian tubules, oviduct. Okay, very good. Shorashi has written common oviduct. Okay, many leveling. Yes, there are many leveling. Shrestha, you are correct. So what are the openings? Again and again I am mentioning what are the opening into the genital pouch. There is the opening called vagina, or you can see the opening of common oviduct. Okay, that is something opening into the genital pouch. Though from the both the side, collateral glands are also opening. And one more thing, we cannot forget the name of last thing, that is called spermatheca. That's called spermatheca. You can see this is the right side spermatheca, which is very well developed. The left side spermatheca is not well developed in most of the cockroach. In most of the cockroach, the left side spermatheca is not well developed. Hope you can follow me. The right side is developed in such a way. The left side is developed not in a good way. And this is called the opening of the spermathecal. This pore is called spermathecal pore. This pore is called spermathecal pore, and that is also opening in the genital pouch. So guys, please remember, three important things are opening into the genital pouch. Okay, collateral gland, common oviduct or vagina, and also spermathecal pore. So these are the three things opening into the genital pouch. Opening into the genital pouch. Though the genital pouch are having the two parts, above the level of the collateral gland, GC, and below V. So GP has two parts. Above is called GC, lower is the V. So you can also draw in my pattern what is GP, what is GC, and what is V. All right. So the last thing is that, suppose they are doing the sexual intercourse, or suppose this male cockroach is sending their sperm. How it is possible? The sperm is, they are sending the sperm, and each of the sperm, they are glued and they are released in formats of the packet or packet. So these are the packets of the sperm. These are the packets of the male cockroach ka sperm, known as spermatophore. So don't get confused. These words are very important. Spermatophore. In biology, the phore means hold. Phore matlab hold. So this spermatophore matlab they will hold the sperm. This structure is holding the multiple sperm. This entire spermatophore that will be held here. That spermatophore will be passing here. They will be temporarily storing here inside the, this is called spermatheca. So this will be held in the spermatheca. And what will happen then? That this ovariole, in the ovariole, what happens? In the ovariole, multiple egg cells, they are waiting in a row. And they are also getting released by the common oviduct. And here the male, spermatophores are already storing here. So the fertilization process, what is the site of fertilization? The site, like in our body, ampulla is the site of fertilization, and their body, the site of fertilization. In their body, the site of fertilization is mainly the this vagina, or you can say common oviduct. There will be the site of fertilization, and once the site of fertilization, zygote will be formed. Once the zygote will be formed, multicellular formation, multicellular stages will be there. Multiple embryos will be formed, and how many embryos will be packed? In the single casing? There is a casing like of thing. How many embryos will be? Who can tell me how many casing will be there? No, how many casing? Very good. Ootheca. Very good. Ootheca. Okay, so very good. 9 to 10 ootheca and 13 to 14 eggs. Very good. So near about 13 to 14. 13 zygotes, or you can say 13 eggs will be cased in a single casing, and the casing will be made up of, I have already mentioned, the casing cover will be given by the collateral gland. So please remember, the only two questions are very important here. That is the site of fertilization. What is the site of fertilization in the body of the cockroach? What is the site of fertilization in the body of the cockroach? And who will give the utheka cover? This is called the utheka. The entire thing is called utheka. This entire casing, this after the casing, the thing is called utheka. This is called utheka. So utheka covering, it will be released by the collateral gland. 13 eggs are there inside the inside per egg, and such egg will be formed 9 to 10. Okay, and 9 such, you write 9 such, so 9 such eggs, each egg containing 13 9 such ukaineti, sorry, 9 such not ukaineti, sorry, 9 such utheka, 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 9 such utheka will be 9 such utheka. Each utheka contain 13 eggs. Each utheka contain 13 eggs. So done. Hope you have enjoyed. Can we move to the body fluid and circulation? Okay. Hope you have enjoyed. Guys, hope you have enjoyed. 9 utheka, correct. Site of fertilization, I have already mentioned the site of fertilization. The site of fertilization is the vagina. The site of fertilization is the vagina or common oviduct. Hope you have enjoyed this entire revision. I think it's very helpful, right? It's helpful. Okay, all right. Can I move to the next one? Okay. So site of fertilization, how many utheka? 9 such utheka. Or I can write 9 utheka. If you want me to write, I'm writing 9 utheka, 13 egg. 9 utheka, each utheka 9 eggs. Okay, each utheka 13 eggs. Each utheka 9, 13 eggs. Okay. Now I am moving to the body fluid and circulation. Body fluid, whatever the sentence I'm directly throwing to you guys, that will be actually copied. That will be actually given in your actual exams. That's why I'm saying the sentences, direct clue, direct sentences. Okay, now again the same thing. Let us practice some amount of some questions on the true and the false, which are exactly NCERT sentences, because before the NEET examination it is important to remember the NCERT line as well. So first is the simple organism like sponges, ciliate, circulate the water from their surroundings through their body cavities to facilitate the cells to exchange these substances. More complex organisms use special fluids within their bodies to transport such material. So what they're saying, simple organism like sponge, you know already sponge ka body mein kya hota hai? There is something chote thing that is called ostia. They are absorbing the water with the help of the ostia. Okay, and ciliate circulate the water from the ciliate and sponge, both are doing the same thing. So if I talk about the hydra also, they are also there is also only one opening called hypostome. Through this hypostome they are actually collecting the water. So they have opening collecting the water from the surrounding, and they are circulating it to exchange the substances, and that is the only way to exchange. So that is true sentence. Okay. Next, fibrinogens are needed for the clotting of the blood. Not only the clotting of the blood, fibrinogens are also there. I hope you know in the semen also fibrinogens are there. So that's why the semen do clot as well. So wherever you will find the fibrinogen, okay, that will clot. Okay, that will clot. So fibrinogens are needed for clotting and coagulation of the blood. Correct. Globulin primarily involved in the defense mechanism. Which globulin? That is known as gamma globulin. You can say immunoglobulin, or you can also say antibody. I will say a lot of MCQs on the antibody. Antibody is a lot of MCQ. Okay, heavy chain, light chain, where there is disulfide bond. Why there is disulfide bond? Because disulfide bond are actually formed in between two amino acid which are sulfur containing. So two sulfur containing amino acid in between, they are forming actually disulfide bond. Very good. So defense mechanism of the body, and albumin helps in the osmotic balance. Absolutely correct. Please remember guys, it's very important that in our blood we have to maintain some pi. Do you know pi? Pi is the osmolar pressure. Pi is equal to, we know in chemistry we have read pi is equal to I into C into R into T. So the pi in our body is mainly maintained by NaCl, because here the I is equal to 2 Na plus and Cl minus, two particles are there. But next to the NaCl, which the substance which maintain the osmolarity of the blood. What is the purpose of the osmolarity of the blood? If you have good osmolarity in the blood, that will actually absorb the water. That will actually absorb the water. If you have good amount of the pi, more the water reabsorption. More the pi, more the water reabsorption. So please remember, that's why this osmolarity is very, very important. And next to the NaCl, albumin is playing the main role of maintaining the osmolarity. Yes. Yes, correct. Reabsorption of the water. Okay. Next, plasma also contains a small amount of the minerals like sodium, calcium, magnesium, bicarbonate, chloride, etc. Glucose, amino acid, lipids are also present in the plasma, as they are always in transit of the body. So basically you have to remember the small molecules, though we will read very soon in the biomolecule chapter the definitions of the macromolecule, micromolecule and the intermediate molecule. Any molecular, guys, please remember here the context, as the contexts are coming, that's why I'm discussing. So please remember the biomolecules, please remember the biomolecule are divided into three parts. One, less than 1000 Dalton. One, more than 10,000 Dalton, and another one between 1000 to 10,000, 1000 to 10,000, 1000 to 10,000. Less than 1000 Dalton, guys, please remember, less than 1000 Dalton, it is called micromolecule. Less than 1000 Dalton known as micromolecule. More than 10,000 Dalton known as macromolecule. And 1000 to 10,000 Dalton, please remember, this is something called intermediate molecule. And hope you know that the molecules, suppose there is something called CCl3COOH. This is called trichloroacetic acid. Okay, this trichloroacetic acid, please remember, this is a cheesecloth. Suppose this is a cheesecloth, and on this cheesecloth, suppose you have given the molecule of interest, because you want to know whether this is a macromolecule or micromolecule, and you are adding the trichloroacetic acid, CCl3COOH. If you put the trichloroacetic acid, you will see that they are forming some slurry, and it is not getting dissolved. All right, so that means that they are forming AIF. What is AIF? Acid insoluble fraction. They are forming acid insoluble fraction. Acid insoluble fraction is guaranteed with this one. Guaranteed with this one. That is the macromolecule. It is guaranteed. Acid insoluble fraction is not usual, is absent for micro, and for them it is acid insoluble fraction can be plus minus, cannot be. Only one exception, that is lipid. Lipid is something whose molecular weight is less than 10,000 Dalton, still the AIF is present. So only this is very exceptional, that's why we cannot make any definition with exception. So acid insoluble fraction present in lipid only, that's why the lipid is shifted to the macromolecule group. And some people also mention that lipid is the controversial macromolecule. Some people also say the lipid is the controversial micromolecule, but it is acid insoluble. All right, okay. Any confusion regarding this? Okay. Next, we are moving to this sentence that plasma do contain. So, okay, so what do you think that if I talk about the plasma, whatever you want, these are present. Like plasma, ions present, glucose present, amino acid present, bilirubin, biliverdin present in plasma, because plasma matlab total blood, just you remove the cells, whatever remaining known as plasma. A healthy individual has 12 to 16 gram of hemoglobin in every 100 ml of the blood. That is correct. Please remember the unit of the protein. Whenever we are talking about the protein, do you know the albumin, how much albumin is present? Albumin present 2 gram per 100 ml blood. Do you know how many globulin is present? Globulin is present. What is how many albumin, how much albumin, how much globulin? Please remember the ratio of the albumin and globulin. Albumin is actually present more. Albumin will be 4 actually. Albumin will be 4 gram per 100 ml, and this will be 2 gram per 100 ml. Okay. This will 2 grams. So protein and hemoglobin also protein. So it will be, the unit of this will be in gram, not in milligram, because they are present in great amount. They are present in very great amount. Okay. I mean the weight of the protein is high. Weight of the protein is their weight is high. So that's why hemoglobin 12 to 16 gram, and you can say that the albumin, globulin, they are also, the unit should be in gram only. The basophil, now this sentence is very important for exam purpose. The basophil secrete the histamine, basophil secrete the serotonin, basophil secrete the heparin. Before that, I want to say what is histamine. Histamine is the amino acid, and that is the histidine. We have just decarboxylated it. So histamine is decarboxylated amino acid. Please remember, histamine is decarboxylated amino acid is histamine. It is allergy mediator. Serotonin, it is another allergy mediator and also released by the basophil cell. Heparin is actually, it is heteropolysaccharide, HPS. I am writing the heteropolysaccharide. There is a list of heteropolysaccharide, that what are the molecules, and please remember that heparin, that is a HPS heparin. This heparin is anticoagulant. It is anticoagulant. Hope you can remember, even we have read the heparin in case of dialysis of human. In case of dialysis of the human, whenever we are collecting the blood from the body and we are putting it into the dialysis machine, in the machine the blood may get clotted. That's why we inject the heparin in the machine, and after the dialysis process, when the blood is filtered with the help of this principle of dialysis, then we are taking back the blood and putting into the vein once again. And before that blood putting into our body, we are adding something called antiheparin, protamine, antiheparin or protamine. Okay. Next thing is that you have to remember, so heparin, it is anticoagulant and it is heteropolysaccharide. Now write down please list of heteropolysaccharide in biology. Please write down HPS, biomolecule. This is a question from the chapter biomolecule. What are the molecules? List of heteropolysaccharide molecule. In exam, it's very important. Number 1, write down pectin. Hope you know pectin. Yes, cell wall. Pectin, plant ka cell wall. Okay. I will do one thing for the plant. I will write here. Okay. For the plant body, if the molecule body is for the plant, I will write here. If it is animal, I will write here. But there is also in the the bacteria also. In the bacteria also, please remember, in the bacteria also, peptidoglycan, murin, these are the things present, and that is also heteropolysaccharide. So in the bacteria, you remember there is a purine, murin, not purine. Purine is different thing. It's murin, or peptidoglycan. I'm right, peptidoglycan. That is also heteropolysaccharide, because NAG and NAM, two kinds of sugar, two kind of monosaccharides are there. Okay, all right. Next, in animal, can you mention one heteropolysaccharide in animal? I'm giving you the hint. In animal, please remember, in the chapter of class 12, at that point of fertilization, you have read something called hyaluronic acid. Hyaluronic acid, that is heteropolysaccharide. Not only that, you know very well, suppose this is the egg ka cell membrane. There is egg cell membrane and vitelline membrane, and above it there is something called zona pellucida. So in between the zona pellucida and vitelline membrane, there is a space that's called perivitelline space, and at that space, once one sperm enters, at that space some heteropolysaccharide molecule known as cortical granule. So please remember cortical granule. What is cortical granule? So hyaluronic acid present. So hyaluronic acid is heteropolysaccharide. Cortical granule is also heteropolysaccharide. बहुत बढ़िया. Okay, very good. Okay, very good. Okay, hyaluronic acid. Okay. Okay, next, number 3. What are the other molecules? Heteropolysaccharide. Heparin. We have already mentioned heparin. Next, what are the other animal molecule? Write down blood group antigen. You know blood group antigen? Yes, blood group antigen. A antigen, B antigen, O antigen. These all antigens are actually heteropolysaccharide. Okay, so we have mentioned all the heteropolysaccharide in one go. It's very, very important. Can you mention? Okay, very good. Chitin, is it hetero? No. Chitin is fungal cell wall component, and it is homopolysaccharide. All right, that is homopolysaccharide. Yes, Shrestha has said the right way. Shrestha is right. Okay. For inulin, it is. What is inulin? Inulin is a fructose polymer, and you don't mention that is homo or hetero. Actually, inulin is mainly made up of fructose, but some bits of other monosaccharides are also there. So your books are not mentioning that inulin as homo, neither homo nor hetero. Okay, just you mention it's a polymer of the fructose, and some other things are also there in the inulin. It's mainly required for the kidney function test. Whether the kidney is performing well or not, that is measured by the inulin, because our kidney does not absorb a single molecule of the inulin, and entire inulin will be excreted via the urine. Thereby we can measure the performance of our nephron, and that's why you remember that inulin is used in the kidney function test. Very good. Kidney function test. Sharnodeep, yes, you have mentioned in a right way. Next, eosinophil, 2 to 3% resist the infection. Very good. It's NCERT line. See, actually how this is resisting the infection. It is NCERT line. Actually, they create some allergic response, and that allergic response make us aware that our body is infected by something. So eosinophil, which is actually 1 to 6%, or here you can see 2 to 3%, whatever you will see, that they resist the infection, correct. They also associated with the allergic reaction. It is also correct. They are associated with the allergic reaction. Why? Because the eosinophil, if you see the eosinophil having headphone shaped nucleus, please do remember they have lot of granule type of thing in their cytoplasm, which is bit coarse granule, larger granule, and these granules are made up of a very important enzyme known as histaminase. You might be surprising that histaminase, are they allergy helper? No. Then sir, why they are increased? If you visit a doctor, you can see that if you are a patient of allergy, you will be asked to do the eosinophil count in 100 ml of the blood. But that purpose is different. Our motto is that the eosinophil will resist the allergy and also resist the infection both. So our eosinophil actually combat the allergy. So in a patient with the allergy, the eosinophil count is high in order to combat the allergic reactions, not to assist the allergic reaction. So please do remember. Please do remember. Okay. Please do remember. So please do remember that no, it is not mentioned. Okay. So please remember that histamine, the allergy, what histaminase will do? What histaminase will do? Histaminase will combat. Please remember. Hey, do you have energy? Energy ache? Do you have energy? Ekhon energy lagbe. Okay. So remember this is to combat the energy, during the delivery of the first child. Now the next sentence, you have to say the true or false. During the delivery of the first child, there is a possibility of exposure of the maternal blood to the small amount of the fetal Rh positive blood. Absolutely correct sentence. That's why first baby is not affected. In Rh incompatibility, the first baby is not affected because during the delivery of the first baby, then only the mother will get some RBC from the fetus in the body of the mother, that is Rh positive antibody, and then the mother will start preparing antibody against the Rh antigen. Am I clear to everyone? Is it audible? Am I clear to everyone? Okay. All right. So this is true sentence. Next, in case of her subsequent pregnancy, like second, third, fourth pregnancy, the Rh antibody from the mother, that is Rh negative, can leak into the blood of the fetus and destroy the fetal RBC. Ekdomi tai. During the first baby, mother got the Rh positive antigen. Mother has prepared the anti-Rh antibody in the blood, which is IgG type. Do you know that the Rh antibody is IgG type of antibody? And then the IgG, which is produced in the mother blood, if there is any second pregnancy, then that IgG will enter via the placenta to the second baby, and the RBC of the second baby will get destroyed even in the embryonic phase. All right, because it can cross the placenta. Next, thrombins in turn are formed from another inactive substance present in the plasma called prothrombin. Very good. You remember that prothrombin is getting converted into thrombin in presence of thrombokinase. And thrombokinase is a multi-enzyme complex. Thrombokinase is multi-enzyme complex. Actually, thrombokinase are formed of multiple factors. Hope you know that we have 13 factors in our blood clotting process. and we are saying multi-enzyme, you can also say multi-factor complex also. You can, in NCERT it is written multi-enzyme complex, you can say multi-factor complex as well. Multiple factors, they are forming something called thrombokinase. They are converting prothrombin, which is factor number 2, into thrombin, which is factor number 2A. Once this thrombin is formed, that thrombin will convert the fibrinogen into fibrin. Next, in tissue, some water along with many small water soluble substances move out into the spaces. See, these are the different cells. So these are the different cells. So in the tissue, some water along with the many small water soluble substances move out into the spaces between the cells of the tissues. So this is the, suppose this is the tissue, and you know that some amounts are coming like this and this and this. So they are moving out in the space. So in tissue, some amount of the water along with many small molecules, they're coming out in the spaces between the cells of the tissues, leaving the larger protein and most of the formed element into the blood vessels. No problem. They are not saying about this tissue fluid by the cell. Actually, from the cell, there's very small amount of fluids are coming. They are mainly mentioning that suppose there are blood capillary. Suppose this is the artery, and suppose this artery is forming the blood capillary. Okay, suppose the artery is forming the blood capillary, and from this blood capillary, what is happening? From this blood capillary, what is happening? The fluids are coming out. Okay, so you have to remember that from this blood capillary, fluids are coming out, and you can see this fluid is called the tissue fluid. Okay, so, and when the tissue fluids are coming from the blood capillary, it is very obvious that larger protein will not be able to come at the tissue space. Larger protein still, it stays at the blood. Only the small amino acid, glucose, even ions, they are actually passing into the tissue fluid. Hormones, they are passing, but larger protein, please remember, larger protein will not be able to come into the tissue space. And most of the formed element, obviously not. Most of the RBC, if I draw the RBC, you can see that RBCs are still present here. If I saw the platelets are actually fragmented cells. They are actually tukra cells. Megakaryocyte is the original cells. These are the parts of the megakaryocyte. If you see, only the WBC, then also not all the WBC, only the neutrophil, they can pass from the capillary to this here, to this tissue space. Okay, from the capillary to the tissue space, only the neutrophil can come out of that via the process of called diapedesis. So the neutrophil and the big kidney shaped nucleus containing cell called monocyte, they can do diapedesis. During the phagocytosis, they are actually coming out of the blood compartment to outside. But other than this, neither RBC nor platelet nor the other WBC, you can expect that they are coming out of the blood compartment. Am I clear to everyone? Okay. Great going. I hope everyone has a very great energy. For this final quicker revisions. Okay. Sir, I'm not getting lacteal. Please explain in brief. I have forgotten about this. See, the lacteal is present in our intestine. If you say this is the villi, in the villi there is a central duct called lacteal, which is actually lymphatic vessels. Okay, anyways, someone's asked and that's why I've answered. Okay, next one. that larger protein forming the elements. This fluid released out called interstitial fluid or tissue fluid. Yes, this fluid is tissue fluid, correct. This is also true statement. Fats are absorbed through the lymph lacteals present in the intestinal villi. Absolutely true statement. In the intestine, if you see the intestine, at the center of the intestine there is something called the lymph vessels, and this is called this closed lymph vessel is called the lacteal. And please remember guys that around it you have something called the blood capillary, which is intestinal capillary, and that intestinal capillary will form a vein, and that vein will again form the capillary, and that capillary, the second capillary, will be formed at the level of the liver. So that second capillary will be formed at the level of the liver. So what is the name of this connecting vein? Name of the connecting vein between the small intestine and the liver, known as portal vein. Hepatic portal vein. So guys, please remember what is hepatic portal vein. The hepatic portal vein is a portal vein present in between the capillaries of the intestine and the capillaries of the liver. Last year NEET 2025 asked another question from the frog that is known as renal portal vein. Hope you know the renal portal vein. This is the kidney of the frog. In the kidney of the frog, guys, please remember one capillary at the inferior extremity, that is the leg, another capillary at the kidney, and this vein and this vein known as the connecting vein is known as renal portal vein. Renal portal vein. Each portal vein, hope you know that they will form the portal vein. Portal vein matlab a special vein. Each portal vein from the second organ, they will form another vein that will drain into the heart, and that is actually known as, for here it is hepatic vein, for here from kidney that will drain to the heart, so that is called renal vein. So what is the difference between renal portal vein and the renal vein? Renal portal is between the inferior extremity and kidney. Renal portal, RP, are renal portal vein, and that is renal vein. Okay, in this case this is hepatic portal vein between the intestine and liver and the heart. This one is known as hepatic vein. So guys, please don't get confused in the exam. I have seen the students are very confused, but you have to remember the difference between hepatic portal vein, hepatic vein, and renal portal vein and the renal vein. Am I clear to everyone? Am I clear to everyone? These are very, very common things. Now if anyone is asking you in which vein you will find maximum nutrition, please do mention the maximum nutrition is found here, because it is intestine, around there is capillary. You will absorb the maximum nutrients here, and that nutrients will pass through like this and this and this, ultimately deposited in the liver. So maximum nutrients are found in the hepatic portal vein. Where you will find maximum urea. Where you will find maximum urea, guys, please remember the urea production house is the liver. Once it is produced in the liver, in each and every cells of the liver, that will be poured into here. So maximum urea is found in the hepatic vein. So maximum urea is found in the hepatic vein, and hepatic vein, yes, hepatic vein, maximum urea. So maximum urea, so I'm just writing for your help that the maximum urea, that is the hepatic vein, hair production, and then it is, you are just dropping it here. So hepatic vein, maximum urea, maximum nutrient, maximum nutrient, that is your hepatic portal vein. Now you tell me minimum urea. See, once you have used your nephrons, and you have done the excretion process, and once it is done, you are forming the renal vein, na? So this renal vein will having the minimum urea. It is having the minimum urea. Okay, so minimum urea, renal vein. Maximum urea, hepatic vein. Maximum nutrient, hepatic portal vein. Please write these three things, very important for the examination. You cannot miss this for examination. Next, the atrium. Next sentence, tell me true or false. The atrium and the ventricle of the same side are also separated by a thick fibrous tissue known as atrioventricular septum. I have seen the students are well confident about the atrioventricular valve, but they are not at all sure about the atrioventricular septum, because most of the students, they are well aware that the right atrium, left atrium separated by interatrial septum, right ventricle, left ventricle separated by interventricular septum, but they're not confident about the right atrium and right ventricle के बीच में कोई septum है या नहीं है. The answer is yes, that is true. This is very important sentence, and I will write N26 against this sentence, because this is a very probable statement that may come in this examination, that whether there is really any septum between this atria of any side and ventricle of this side. There is a small septa type of things that is very important, that is present. Next, a patch of tissue is present in the right upper corner of the right atrium called sinoatrial node. Yes guys, you have to remember, this is the atrium, this is the right atrium, and this is the right ventricle. You have to remember that at the right upper corner, this is called SA node, and this is something called left lower corner of the right atrium called AV node. Please don't forget the locations of the SA node and the AV node, though they are connected in between with the help of three bundles of pacemaker cells. But the important thing is that the SA node, right upper corner, left lower corner, AV node, both are located on the chamber right atrium only, and both the chambers are giving the signal to the nearby atrial myocardium only. Because in a true sense, the ventricle myocardium will get signal by the tissue known as right bundle of His, left bundle of His, and the Purkinje fiber only. And don't forget ever that there is a connecting tissue pacemaker cells known as AV bundle. This is known as AV bundle. AV bundle. And please remember, the signal passing through this AV bundle, the duration is only 0.1 second, exactly that time which is required for atrial systole. Because once you are generating signal with this SA node, AV node, the signal is passed to the nearby atrial myocardium, and after that the systole of the atrium would happen. That time the signal from AV node has already reached, we already traveled the path of this AV bundle. So always remember, the electrical incident in heart happens earlier than that of the mechanical incident. So whatever the electrical signal you have generated, that will cause the subsequent mechanical effect, and that's why whatever the signal we have, positive signal we have generated from SA node and AV node, then and there the mechanical contraction of the atrial chamber will not happen. When the signal is the signal is on the way of AV bundle, then this contraction would happen for 0.1 second. That time, within 0.1 second, the signal will already reach the right bundle and the left bundle. That's why this time is called AV nodal delay. The AV nodal delay. So this 0.1 second is also known as AV nodal delay. That's why it is called AV nodal delay. That's why it is called AV nodal delay. Because why it is called AV nodal delay? Why it is called AV nodal delay, but nodal delay. You can also say nodal delay. Simply you can say nodal delay. Okay, nodal delay. This is AV bundle, and this is called nodal delay. Okay, this nodal delay is very important. This nodal delay is a very internal. Very internal feeling is like broken. Okay, why broken? Muaza, you have written? Yeah. Now, So this is correct, okay? And this nodal delay 0.1 second is the only reason, that's why we are getting the 30% of the blood. Hope you know that 70% of the blood would come automatically, only the 30% would come with active contractions of the atria, and that is only possible for this 1.1 second and AV bundle. So please, everyone do right, everyone does right that 30% blood, 30% blood, 30% active contraction is possible. So 30% blood the ventricle is receiving, and for this reason, complete filling of the filling of the ventricle is possible. That's called end diastolic volume. That's why end diastolic volume at the end of the diastole of the ventricle. That's why we are receiving end diastolic volume or proper end diastolic volume. So that's why we are receiving proper end diastolic volume only. Am I clear to everyone? Am I clear to everyone? The nodal musculature has the ability. So next sentence, can I move to the next sentence? Yes. Can I move to the next sentence? Very good, Arangshi, very good. So next statement number 14. The nodal musculature has the ability to generate the action potential without the external stimuli. That's why auto-excitable. These cells are auto-excitable cells. They don't need any neuronal signaling. They are independent of generating their own signal. I mean, if they are getting depolarized and somehow they are getting repolarized also, they are the moment they are getting complete repolarized, they will again bounce back to get depolarized. So their repolarized state to depolarized state would happen in a rhythm, and that rhythm is automatic. So that's why these cells are known as autorhythmic cells. Okay, on very unique cell in our body. No, there is not a single cell in our body which will be excited on their own. Okay, but this is the only cell which will be getting excited on their own. That's why it is called autorhythmicity. And our heart, that's why our heart is myogenic. Our heart is myogenic. But in case of invertebrates, this such nodal systems are not there. That's why they are called neurogenic. Okay, that's why that is called neurogenic. Now you tell me, the nodal musculature has the ability to generate the action potential without this. So it is true statement. Next, the atrial systole, this increase the flow of the blood into the ventricle by 30%. Absolutely correct. If only with the help of the atrial systole 30% filling is done, because 70% filling, because for the 70% filling, please remember, because for the 70% filling only the opening of the valve is enough. If the atrial valve is getting opened, the 70% filling will be done. Only the contraction would help to do the remaining 30% filling, and within 0.1 second. Next, the ventricle and the atria now again in relaxed stage or joint diastole stage as earlier, so that is 0.4 second. You remember once the atrial systole is done, and once the ventricular systole is also done, there will be a 0.4 second joint diastole when both of the chambers, be it atria, they are receiving blood with the help of vena cava and the pulmonary veins, and ventricles are also they are in the diastole stage because they are receiving blood from the atria. So all the four chambers are receiving blood and present in diastole for 4.4 second. The first heart sound known as lub, due to the closures of the tricuspid bicuspid valves. Ekdam sahi. These are the valves between atria and the ventricle. Big valves, big sound will persist for quite significant long time. And the second heart sound is called the dupe, when the sound will be due to the closure of the semilunar valve. The closures of the semilunar valve. So again I am saying this is the atrioventricular valve. This is closing. These are big valves. These are closing and they are causing the lub, and the small they are small semilunar valve and they are closing and they are creating the dupe sound. Okay, so closure of the semilunar valve, they are creating the dupe sound. That is also Correct. A patient is connected to the machine with three electrical lead. Three types of that one is called lead 1, lead 2, and lead 3. These three lead, and each leads are connected to the one of the wrist and the left ankle. So hope you know that this is the, let's say this is the body, this is the left arm, this is the right leg, left leg. You remember in the ECG, right wrist is used, left wrist is used, left ankle is used, but nothing, no leads are present in the right ankle. Please remember, no leads are present on the right ankle. So that is also the true sentence, absolutely true sentence, very important sentence. The contraction starts shortly after the cue and marks the beginning of the systole. Absolutely NCERT line, and I have seen in multiple examination the student are making mistake. Okay, so please remember the contraction starts shortly after the cue and marks the beginning of the systole. Guys, please remember this is the P wave. Okay, P wave. Then there is Q wave. Okay, there is, you know, R wave. This is the R. This is the S wave. And these are the T wave. So P, Q, R, S, T. So please remember, and very importantly, always remember, these segments are known as isoelectric line. And also this, after this T wave, there is something called, again we can draw something called P, we can draw something Q, we can draw something R, we can draw something S, and again so on. Remember, all this isoelectric line are filled with mechanical happenings. You might be thinking that these are isoelectric lines, so no electrical incidents are there. Absolutely correct. But these are the timing where mechanical things are actually happening. So if this is my P wave, by electrical incident, this is called atrial depolarization. But my okay, all right. So again I'm mentioning the same thing. You might be thinking that there is no electrical incident in this green colored part of the ECG graph, but trust me, these are the most important segments where mechanical incidents are happening. I mean, this is the P wave. This P wave is known, you know, it's very famous for the atrial depolarization. It is very famous for the atrial depolarization. I mean, atrial cells are getting positive signal here. But applying that positive signal, atria will do the contraction, and that contraction will be happening in this PQ interval. So never ever say that atrial systole is happening on the P wave. Audible? Hope it is audible. Hope it is audible. Sorry for the interruption. Hope it is audible. Hope it is audible. All right, all right. Hope it is audible. Please confirm, everyone. Please confirm, please confirm, please confirm. Hope it is audible. All right, all right, all right. So please remember, many times you can see the questions are asking that when the atrial systole is happening, don't say the atrial systole is happening on the P. The atrial systole is actually happening on this PQ interval, which is isoelectric line. By electricity, it is isoelectric line. It is an isoelectric line. All right, now you have to remember that like this is something called QRS. So this is the positive signal generated, that this is called ventricular depolarization, that all the ventricular musculature, they are getting the positive signal by electricity. But are they doing the contraction? The answer is no. They are doing the contraction just immediately after this electrical wave. So this all electrical segment, isoelectrical segments are important for the mechanical incident. Clear? For mechanical incident. So what this NCERT line is saying, contraction starts shortly after the Q. So after this Q, I means QRS is done, the ventricular contraction is happening. So the ventricular contraction is happening here, okay, and marks the beginning of the systole. So don't ever say that during the Q wave the ventricle has started the contraction. Ventricle will start the contraction once this depolarization wave, ventricular depolarization wave is done. Okay, so once the Q is done, you can think that systole, ventricular systole. Okay, I am writing ventricular systole is going on. Similarly, once the P is done, you can think of atrial systole is going on. Am I clear to everyone? Am I clear to everyone? Am I clear to everyone? Okay. Okay. All right. The end of the T wave. Now the second sentence. The end of the T wave marks the end of the systole. Now you tell me. The end of the T wave. So you remember the end of the T wave. What is the meaning? The meaning is that the T wave. You have ended the T wave. T wave matlab ventricular repolarization. Now the ventricular cells are they are becoming again negative. These cells are again becoming negative. So all the positive electricity is over. That means the T wave matlab negativity inside this. That means next it is going to do the relaxation mechanically. So after that you are going to something do that is called ventricular relaxations. Okay, after that you are going to do ventricular relaxations. Okay, so the T wave, so end of the T wave matlab no further ventricular systole is there, but because you have started generating the electricity, negative electricity, you have started generating the negative electricity. So whatever ventricular systole or contraction you want to do, that you have to do before that. Clear? Am I clear to everyone? Okay, bhoon was coming on the time I was explaining, so the bhoon, but automatically you can feel. So is there any surrounding noise, right? A voice like honeybee in the air? Okay, is it fine now? Is it fine now? Everything is audible? Right. So that is also true. The end of the T wave marks the end of the systole. End of the T wave, whatever the systole you want to do it before this time, because after that the mechanical effect of the T wave has to be done. Next, the neural signal through the sympathetic nerves part of ANS can increase the heartbeat, and the force of strength of the ventricular contraction, thereby cardiac output. Bilkul sahi statement. There are three effects of adrenaline in the heart. There are three effects in the adrenaline of the heart. Please remember. Number one, increasing the heart rate. Increasing heart rate because adrenaline gives the positive signal to the AV node. Second, FOC, force of contraction of my normal heart muscle. It's not FOC, increased force of contraction of myocardium. Myoc matlab myocardium. यानी कि each and every myocardial cells, they will start contracting with greater force, thereby generating greater stroke volume. Okay, so the stroke volume will increase. Now you tell me, stroke volume will increase, and as you know AV node is stimulated, so heart rate will increase. So heart rate increase, stroke volume increase, that is cardiac output also increases. Now, hypertension is the term of the blood that is higher than the normal, that is 120/80. See, it's some NCERT has written the hypertension definition in two ways. At the very beginning of the hypertension context, NCERT has written the pressure if it is more than 120/80, it is hypertension. That's why we are also marking the sentence as right. In the another context, just after this sentence, if you can remember, NCERT has clearly mentioned that if in the multiple instances it has been shown that the blood pressure of the patient is more than, either of the blood pressure is more than 140, more than 140 in systole, or if the diastole is more than 90. Actually, this is the correct one. Actually, this is the correct one. But as this sentence, this 22nd sentence is the copied from, directly copied from NCERT. So that's why we are also writing this statement as correct statement, because it is copied from NCERT. But in actual examination, most of the time teacher will try to see that whether you are aware of this concept which is written in NCERT in the subsequent next two lines, that 140/90, more blood pressure more than 140/90, either of the pressure. If the systole is more than 140, let's say 150/70 is pressure of someone, it is also hypertension. If let's say the blood pressure is 120/100, because that also crossing the diastole pressure is high, that also hypertension. Okay, all right. Next, plasma versus serum versus lymph. Guys, please remember, it's very important. Plasma is something, there is no cell minus cell, that is formed, no formed element, so minus cell is important. In case of serum also, there is no cell. Okay, in case of lymph also, can I expect cell in the lymph? In lymph, you can expect only cell, that is the lymphocyte. So I am writing only lymphocyte cell you can expect, because the lymph would be passing through a vessel called lymph vessels, and around that lymph vessels there are a cluster of lymphocyte present. There are cluster of lymphocyte present. All these lymphocytes will drop into the lymph flow, and they will be added into the lymphatic flow. So that's why you can expect only the lymphocyte cells. That is the number one. Number two, if I talk about the clotting protein in the plasma, you will get the clotting protein. You will get the clotting protein, but you will not get the clotting protein in case of the serum. In case of the serum, because serum is the result after the blood clotted. Once the blood is clotted, then whatever is the fluid coming out, that is called the serum. So you cannot expect there that any in heart muscle, true or false. What is the actual question? Anyways, next, in case of lymph, is there clotting protein? See, lymph. Do you think lymph clot? See, when we are forming the lymph, the contraction is happening. Some of the clotting protein may also come, but not all the clotting factors. Total 13 clotting factors are there. So we will write a plus minus. Sometime lymph clot little bit, but not in that much way. Okay. So clotting protein in lymph is not some amount of some clotting proteins are present. Not all the clotting proteins are present. Now 3. If I talk about the bigger protein, if I talk about, in case of plasma, you will definitely get all the bigger protein. All the bigger protein you will get. In case of serum, the bigger protein, no chance, that will be trapped into the mesh of the fibrinogen. You know, fibrinogen. Hope you know the fibrin and fibrinogen. Hope you know the fibrin and fibrinogen. That if you know, hope you know this fibrin and fibrinogen, they will be trapping this, you know, this they will be trapping it. They will be trapping the bigger protein. In case of lymph, you have to remember, the bigger proteins in case of lymph will not be present because lymph is modified tissue fluid. Suppose this is the blood capillary, you know, the blood is flowing within this artery, capillary and all this thing, and the bigger protein will stay inside the blood flow, that will not pass into the tissue fluids. Okay, that's why the bigger proteins are not present. And last but not the least, that is the lipid. Please present lipid. Please mark this. Lipid is very, very important. It is important. If you talk about the lipid, you remember plasma. In plasma, lipid is present. In serum, in case of serum, not that much lipid is present, because lipid is again trapped by the mesh of the fibrinogen during the blood clot, and the lipid is very much present, very much present in the lymph. Please mark this. Lipid is very much present in the lymph because of this lacteal. Hope you can remember. We have discussed in the intestine, we have a lacteal. We discussed now. We have lacteal. And remember this lacteal, this lacteal is famous for reabsorbing the lipid. This is the lipid. The lipid will be reabsorbed into the lacteal. And this lacteal is lymph vessels. As you know that in our body, blood vessels, in our body, blood vessels, all the blood vessels are connected. You have to remember that in our body, lymph vessels are also connected. In our body, all these lymph vessels are also connected. Okay, so as in the body, blood vessels are connected, lymph vessels are also connected. Lymph vessels known as lacteal at our intestine. Lacteal is the lymph vessels at our intestine that is absorbing lipid. So that's why all the lymph vessels, they would be getting the lipid as well. And as a result of that, lipid is having very, very good amount of the lymph is having very good amount of the lipid as well. Universal donor versus universal recipient with logic. Guys, please remember universal donor, whenever you are writing the DONOR, you can write the O in a bigger version. DO, so big O's. So it is blood group O. Blood group O is the universal donor, that you can also remember. It's a very beautiful, easy way to remember. But actual concept is that whoever is donor, those RBC should not contain the antigenic carbohydrates. I hope you know that the blood group antigen is carbohydrate that is present in the format of the glycocalyx on the RBC cell membrane. If it is a universal donor, if anyone is a universal donor, the antigen should be as minimum as possible. That's why I am cutting all this antibody. I am erasing this antibody from the surface of this RBC membrane, and now you can say this person is the universal donor, and the person with the blood group O is not having significant antigen on the RBC surface. So that's why I'm writing this. The blood group of the patient is blood group O. So please remember, understand the logic. The blood group O patient is not having much more antigen on RBC membrane, and that's why their blood can be donated to anyone, and that's why they are universal donor. And a quick technique to remember: donor double O and double O donor. Am I right? Okay, audible. Okay, very good. Now universal recipient, for receiving the blood, the RBC is not the main criteria. If I want to receive the blood of any person, I have to ensure that my blood plasma support suitable environment for the survival of the RBC that I have received. So it is important that plasma. So let's talk about the plasma in the recipient. Whenever we talked about the donor, we talked about the RBC. Whenever we are talking about the recipient, we will talk about the plasma. Okay, so it's very important that we have to know which one is important for donor, which one is important for the recipient. For the recipient, plasma is important, and for the recipient it is important that what are the antibodies are present. It is always well acceptable for universal recipient that as minimum antibody as possible, and you know that in a person having the A, B, both the antigen on the surface, they will have no antibody in the plasma. So the person with AB, they are almost having no antibody in the plasma. That's why they are universal recipient. Am I clear? Am I clear to everyone? So I have explained you the universal donor and recipient logic with explanation. And always remember, blood group antigen, its genetics is important. Its genetics actually relevant to the molecular principle of inheritance of class 12. Hope all my dear students, you have already read that thing, that what is concept of IO. This is the allele. The another allele is IA, another allele is IB. And I hope you know, if IO, IA togetherly present, that's the heterozygous A blood group. If IOIB is present, heterozygous B blood group. If IAIA is present, homozygous A. IB homozygous B. IOIO obviously homozygous O. So I hope that you are pretty sure. Aniket is saying only 2 days left, sir. Don't cry. Okay, don't cry. Be strong. Obi Priya Bharat, sir, what will happen if the person is having AB negative and AB positive? In both of the cases, you remember whether it is AB positive or AB negative, we will consider both of them are universal recipient because they don't have any antibody. Be it AB positive, be it AB negative, both of the person will not have any antibody in the blood. Both are universal recipient. All right. Next, so in genetics, you just have to remember a lot of questions are there. Father is having, let's say, this blood group, mother is having that blood group, father is having A, mother is having B. How much baby can have O blood group? How many babies can have O blood group? You remember, first of all, if the father is homozygous A, that is IA, and IB, mother is B, that means if mother is homozygous also IB, then in such combination no baby will be O blood group. But if the father is heterozygous A, that is IO and IB, mother is also heterozygous B, that is IO and IB, then only it is possible combining this to O, the baby may have the blood group IO will be the combination of the genotype, and baby may have the blood group O. So please, all this genetic aspect has to be very clear. Now the inheritance aspect, the such questions, inheritance aspect, and then the biomolecular aspect. I hope everyone is aware of the fact that if this is the RBC membrane is having the carbohydrate on the cell membrane, and that is also heteropolysaccharide. Just few minutes ago I have mentioned this is called the heteropolysaccharide present on the RBC membrane. Yes or no? Yes or no? Yes or no? Yes or no? Have I mentioned this? Have I mentioned it? Have I mentioned it? Okay. Shrestha, yes, very good. Now open and closed circulatory system. See, first from the animal kingdom aspect, I want to mention everyone that open circulation is something where you have to remember the examples. The simple examples I am saying, let's say the close examples. Close are less. So from invertebrate, annelids are closed. There are only few examples. From invertebrate, only one type of mollusca are closed. That is called cephalopoda. Who are cephalopoda, guys? Please remember, guys, cephalopoda are octopus. This is the brain and this is the legs. So the legs are coming from the brain. That's why they are called cephalopods. So cephalopoda are octopus-like, squid-like mollusca, and you have to remember they are closed circulatory system. Number 3, what we can expect? Next we can expect from the cephalochordata only. Next we can expect from cephalochordata only. So hemichordate and urochordate, we are not saying they are open. Cephalochordate onward, matlab aapko samajh mein aa raha hai, I think that cephalochordata onwards matlab cephalochordates and vertebrates, they are having the claws. So it is very clear that all the other animal kingdom ka phylum jitne sare hai, these are actually they are actually open circulatory system. All right, am I clear to everyone? Am I clear to everyone? So we are moving to the next topic. The next topic is the complete circulation versus incomplete circulation. What do you mean by complete circulation? Complete circulations matlab, suppose complete circulation matlab, if we have four chamber in our heart only, that is possible only two classes. One is aves and another is mammalia. So only for this two class, again and again I am repeating the taxonomic category for your better remembrance, so that you can remember in exam well that these are two classes, and rest of the classes of subphylum vertebrata, rest of the classes of the subphylum vertebrata, like pieces is, though it is super class, so better I will mention the chondrichthyes and osteichthyes separately. So if I talk about the osteichthyes, if I talk about the chondrichthyes, if I talk about, these are the classes. If I talk about, amphibia, if I talk about, reptilia, these are the four classes. The amphibia and reptilia superclass tetrapoda, osteichthyes, chondrichthyes superclass species. Aves is also tetrapoda, mammalia is also tetrapoda. So they are having like either one atria, one ventricle, or two atria, one ventricle, or two atria, semi-divided ventricle. So okay, all right. So now you have to remember they are complete circulation, because right atrium receiving blood from vena cava system, superior and inferior, right atrium to right ventricle, then the blood is going to, that is something called pulmonary artery. The pulmonary artery is sending the blood to the right and left lung capillary. In the lung they are forming the capillary, and the capillary are actually getting the oxygen from the alveoli, and the blood around the lung, they are get purified. Once it is purified, that purified blood will be poured into the LA. All right, so you have to remember that if we consider from the RV to PA to lung to LA, this circuit is actually lung circuit. This circuit is actually RV to this to this to this. This is called lung circuit or pulmonary circuit. This okay. Now if I talk about the once the blood has entered into the left atrium, what is the next fate? The next fate, you can see left atrium, it is going to the left ventricle. Left ventricle, it is going to the aorta. From the aorta, it is going to the different part of the body, and the blood around the tissue, and the blood getting the lot of CO2 from the tissue, and that deoxygenated blood is passing through the vena cava and ultimately entering to the RA. So the second circuit that I am mentioning, that is called systemic circuit. From the LV, the second circuit that I am mentioning is called systemic circuit. Okay, LV to this to this to this to this to this RA. So starting from LV ending at the RA. So two type of circuit, that's why it is called the complete. So for two types, for complete circulation, 4 chambers are required. But if I are not getting the 4 chamber, it is not possible to form the complete circulation. Now we are moving to the next topic. The next topic is the heart failure versus, okay, it's a very interesting topic, guys. Get energized. It's a very, very interesting topic. Heart failure versus heart attack versus heart block versus sudden cardiac death versus cardiac arrest. How many of you are aware of this? Please keep writing. Are you really aware of this all facts, that what is heart failure, what is heart attack, what is heart block, what is sudden cardiac death, and what is cardiac arrest. So let's start one by one. First, heart failure. Heart failure is the pump failure. I have a heart. That heart is supposed to pump my blood for all the organs. Suppose my heart is unable to pump. The blood to the rest of the organ. What would happen? All the organs, they will not receive adequate blood. All the organs, they will not receive the adequate blood. If all the organs are not receiving the adequate blood, what will be the problem? NCERT has written the first problem as the accumulation of the blood here. So if you are not pumping the blood, it's very obvious that the blood will be staying in the right ventricle and the left ventricle, because you are unable to pump. If you are unable to pump, you should not expect the emptying of the blood from here to here and here to here. As a result of that, the blood will be even accumulated in the atrium. What's next? If the blood is getting accumulated in the atrium, you should not expect that the vena cava and the pulmonary artery, they are releasing the blood into the right atrium and the left atrium respectively. So what would happen? That if you think about the capillary, from where they are bringing the blood, hope you know the capillary. You know these are the capillary around the alveoli. Hope you know these are the capillary around the alveoli which is bringing blood to the pulmonary vein. And hope you know this is the this is our body cells, body tissue around which the capillary is formed, and via the vena cava the blood is coming to the right atrium. So now what would happen? The forward flow of the blood is not possible. As the forward flow of the blood is not possible, blood will be staying here, blood will be staying here, blood will be staying here, blood will be staying here. Now think about this capillary and about this capillary. The blood is staying here, blood is staying here. So the pressure is high here, pressure is high here. So what will happen? In high pressure, the blood will be leaking out. In the high pressure, blood will be leaking out. Here the plasma will be leaking out. The fluid will be leaking out. And the lot of tissue fluid will be formed. Lot of tissue fluid will be formed around the tissue. You can see the patient with the heart failure is having the swelling in the leg, swelling in the hand, swelling in the face, due to this accumulations of the fluid around the tissue. And in the another side, left side symptom, there is the pressure is high even in this capillary. So the blood is leaking, blood is leaking out, and now the fluid is accumulated inside the alveoli as a symptom of the heart failure. NCERT has clearly written this as lung congestion. So you can clearly see the patient of the heart failure is having respiratory trouble, and if you do the X-ray of those patients, you will see that the patient of the heart failure is having the very not a clear X-ray. The X-ray will be very hazy in this area. Why? Because due to this lung congestion, the alveoli is holding water. So hope you got that idea. All right. Now what is heart attack? Now the next concept. So we have discussed about the heart failure. Now how we can measure the heart failure? It is very easy. Do the USG of the heart. That is called echocardiography. USG of the heart is called echocardiography. And you can see in case of heart failure, cardiac output of heart is less. That is visible in echocardiography. If you do echocardiography, you can see cardiac output from the heart is very less. And as a result of that, you can diagnose that it is heart failure. Okay, heart failure completely done. All the important points I have covered. Heart attack. Heart attack is something, the main reason of the heart attack is that the feeding artery of the heart, these are called coronary arteries. These coronary arteries are like present like these and these and these. They are passing through the myocard, actually above the myocardium they are passing, and they are actually supplying the nutrients to the working, contracting, whatever you say, this myocardial cells. Somehow if you are blocking, or you are, suppose the blood is not able to flow, let's say maybe there is an obstruction of blood flow, of the blood flow at any point of this coronary artery. Let's say there is obstructions of the blood flow at any point of coronary artery. From that point forward, blood flow is not possible. As a result of that, from that area where there is a obstruction in the coronary artery, forward to that, blood supply is compromised to adjacent heart muscle. Blood supply is compromised to adjacent heart muscle, and this heart muscle will die. Due to the lack of the nutrient and lack of oxygen which they are supposed to get, but they are not getting due to the block obstruction of the supplying feeding coronary artery, and this heart muscle is dying, leading to heart attack. This is called heart attack. Do you understand, dear student, all my student? Do you understand what is heart failure? And any part of our body, when they are not receiving adequate oxygen, there will be pain. So any heart attack will lead to pain, and the pain is just behind this breastbone. Hope you know this breastbone known as sternum. Just behind that there will be pain. Okay, and that pain in heart attack known as angina pectoris. Angina matlab pain, pectoris matlab chest. So this is the pain behind the sternum. Retrosternum chest pain is called angina pectoris. So heart attack. Now can you tell me what is this obstructions of the coronary artery is actually known as? This is known as atherosclerosis. So hope my students are aware of atherosclerosis. Atherosclerosis in any artery of our body. If you see, let us draw a cross section of the artery of our body, and I have drawn the I have drawn the artery. So there are, I hope you know that there are layers: tunica intima, tunica media, tunica externa. These are the three layers of any blood vessels, and inside that we assume that the blood is flowing nicely, but at any point if we find that there is a cluster, there is accumulations of the cholesterol, there is accumulations of the lipid, there is accumulations of the platelet is there, very very sticky to the endothelium. There is accumulations of, let's say, calcium, and there is accumulation, let's say, LDL matlab it's one type of lipoprotein. All these accumulations will form a cap-like structures. That cap-like structures is blocking the lumen of the lumen of the artery, making the lumen of the artery narrower. And this problem is known as atherosclerosis. What kind of surgery we do? We can change this piece of small artery with new piece of artery known as plasty, angioplasty, new vessel formation. This is the most we do this treatment in most advanced cases or most high graded cases. But beforehand we try to do one thing, that is something called that is actually bypass. The artery is cutting and again new artery is giving, that is called bypass surgery. And we can do one thing, that we are placing a small balloon, and that balloon we are inflating the balloon, we are pressing this atheroma plug, and thereby suppose this is a small thing, the small atheroma, this is a small balloon, we are inflating the balloon, and that's why this small atheroma plug getting crushed. Okay, not crushed, actually getting squished. So, and we are making the lumen bit narrow, a bit wider, and more oxygen can flow, your heart will be saved in this way. Okay, so the treatment, so heart attack, this is the treatment, one treatment. So what are the treatment? Chalo write down. Heart attack ka treatment is very important. One most important treatment of heart attack written in the chapter microbes in human welfare is the application of the streptokinase. So streptokinase use. What is streptokinase? Hope you know this is the product of the bacteria Streptococcus. Hope you know that this is the product of the bacteria Streptococcus. Streptococcus bacteria gives a product called streptokinase. This streptokinase break the fibrin, because we have already discussed that not only the platelet, cholesterols, lipids, all these things, you have to remember, just like clotting mechanism, even in the atheroma there is presence of fibrinogen. So you can break that fibrinogen with streptokinase. So please remember, streptokinase break fibrin. So it break the fibrin, and thereby it can dissolve such clot known as atheroma. So streptokinase is very important treatment of heart attack as well. Along with that, you have to remember, there is something called balloon angioplasty. I have mentioned balloon can be inflated, known as balloon angioplasty. This is called balloon angioplasty. New vessel formation can be done. And third is called the bypass surgery. The bypass surgery. Bypass surgery is actually when this artery is blocked, we can add new artery, like from here to here. So we are bypassing, this is blocked, so we are creating new artery, we are joining new artery here. So all the bloods, they are flowing like this, they will not go here. Now the blood will be bypassed, to another route. It is bypassed to another route, and thereby suppose this artery is blocked. So what will form? We will bypass this artery. And this new route, with this new route, the blood will be reaching to the problematic area, and heart attack will be saved. Okay, now the heart block is not a problem of the artery. Most of the students, they think that heart block is just like the artery block. No. Heart block is the problem in pacemaker cell. So heart block is the problem in pacemaking. So the pacemaking is the problematic thing in heart attack. That's why in heart block. So you remember, in heart block, the problem is a pacemaking block. Heart block is actually pacemaking block. Heart block is the pacemaking block. Your P wave, your Q wave, RS wave, this wave will not be properly formed. Okay, you will be getting P wave, and you are not getting, let's say, QRS wave. So this kind of blocking we are getting. So in heart block, mainly the problem with the heart rate. You can see in a patient with heart block, the heart rate is very slow, because the pacing by the SA node and AV node is not proper. So, okay, though there are a lot of primary block, secondary block, complete heart block. So in every block, you remember the pacemaker cells, SA node and AV node, they are not doing their right function. Sudden cardiac death, it's a movie scene. Hope you can remember. Suppose from this graph, immediately you are getting P. So your heart, SA SA node, AV node, they are not generating any signal like P, Q, R, S, T, not getting P, Q, R, S, T. Okay, PR interval more than this. Okay, so your heart interval, correct, PR interval will be longer, no doubt. Your PR interval will be longer, no doubt. Okay, so sudden cardiac death, matlab there is the PQRST wave is not there, and that sudden cardiac death and cardiac arrest is same. That is also called cardiac arrest. That is also called, that time you will also see that you will also see there is no PQRST, and that will be known as cardiac arrest. Okay, now the count RBC, you have to remember what is the count of the RBC. RBC is a 50 lakh to 55 lakh, 50 lakh to 55 lakh, you can say, or you can say 45 lakh to 50 lakh also, but 50 to 55, 55 is in male. Why in the male the RBC is more? Due to the presence of the testosterone, due to the presence of the testosterone, and due to the presence of the T3 T4, because in the male T3 T4 is also more. What are the hormones helping in the formations of the RBC? Number 1, cortisol is helping in the formations of the RBC. Number 2, T3 T4 is helping in the formation of the RBC. Guys, please remember, it is also the erythropoietin, EPO, that also helping in the formations of the RBC. And last but not the least, that is the testosterone also, it is helping in the formations of the RBC. So male is having the RBC count like 50 to 55 lakh. Absolutely correct. Platelet, the count you can say 1.5 lakh to 3.5 lakh is the platelet count per mm cube. Next, eosinophil, no specific count is required, but the percentage you have to remember. Basophil is 0 to 1%. You have to remember basophil is 0 to 1%. 1%. These are in percentage. Eosinophil is 2 to 3%. We have just solved few MCQs. Monocyte, it's 2 to almost 8%. And neutrophil is 65 to 70%, you can say. Lymphocyte is almost 20%. B and T togetherly, you can say 20% of the lymphocyte. That's more than enough for the question. This picture can be asked in NEET to N26. What are the important pointings in black and white diagram, and you may make mistake during the exam. That's why I'm marking. First is the pulmonary artery. It will be black and white. In the examination, it will not be in the red and blue color. So you have to remember by shape, not by the color. So you just remember the shape. This shape will tell you this is aorta. This shape, you can see that there's something two, you know, in the left also, you know, there are two pulmonary vein. In the right also there are two pulmonary veins. So by this shape, you can expect that this is the pulmonary vein. Pulmonary artery, if you want to see here, no, sorry, it's not pulmonary vein. This is pulmonary artery. This is pulmonary artery. Okay, this is pulmonary artery because this is coming out from the right, you know, ventricle. So this is pulmonary artery. This is pulmonary artery. This one is the pulmonary vein. Extremely sorry. This is the pulmonary vein. This two. This is this two. So this is pulmonary vein. This is pulmonary vein. This is pulmonary vein, this is pulmonary vein. Okay, these are pulmonary vein. Okay, now these are the valve, these are the semilunar valve. These are the right side, so tricuspid valve. This is the left side, so bicuspid valve, and these are again semilunar valve of this route. So these are semilunar valve of this route. That is also semilunar aortic valve. This is called aortic valve. This semilunar valve is called pulmonary valve. Chordae tendineae is very important. It is a part of the valve complex. The valves are attached directly with the tendon-like structure called chordae tendineae. This is called chordae tendineae. Now, breathing and exchange of gases. Breathing and exchange of gases. They are breathing and exchange of the gases. Okay, breathing and exchange of gases. Okay. So now the sentences again. Okay, all right. Now the sentences very important. So you tell me, earthworm use their moist cuticle. Earthworm use their moist cuticle. So we'll revise the entire thing. Earthworm use their moist cuticle. Do you have energy? Okay, all right. Everyone has energy. Everyone is okay. Can we continue the session? Okay, all right. So earthworm use the moist cuticle, and insect have network of tube called tracheal tube. Correct. Insect are having the tracheal tube that is unique to the insect. all these small spiracles, they are leading to the tube-like structures called tracheal system, unique for the insect only to transport the atmosphere air within the body. That is true sentence. Next. Purnashi is saying yes. Swarnadeep is saying yes. Okay. Next, trachea is a straight tube extending up to the mid-thoracic cavity and which bifurcates into two primary bronchus at the level of the vertebra T5. At the level of the vertebra T5. That is also true sentence. Next, the trachea, primary, secondary, tertiary bronchial, tertiary bronchus and up to initial bronchiole are supported by incomplete shaped ring. Yes, this ring is no more into the further bronchioles. These rings are present only up to the initial bronchiole. Correct. The part is starting with the external, the part starting with the external nostril up to the terminal bronchiole constitute the conducting part. Correct. So always remember, up to terminal bronchiole it is conducting part, and from that is the respiratory bronchiole, alveolar duct and alveoli. These are called respiratory, that is called exchange zone. That is called the exchange zone. Okay, that is called the, but that is the exchange zone. Okay, we are writing little less energy, but I will gain it again. Okay, all right. The alveoli and their duct form from the respiratory or the exchange part of the respiratory system. Okay, form. This is not from, this is the form. Okay, so the alveoli and the duct of alveoli, they will form the exchange zone. Correct. I have already mentioned that up to the respiratory bronchiole we have to, up to the terminal bronchiole we have to remember conducting part, and after the conducting, after the respiratory, after the conducting bronchiole, then the next is respiratory bronchiole, alveolar duct, respiratory bronchiole, alveolar duct and alveoli. Only these three zones are helping in the exchange of gases with its surrounding blood vessels. So only the exchange zone, if I say the exchange zone is only present in these three. So the exchange zones are present only in this three region. The exchange zones are only present in this three region. Again I am writing, one is called respiratory bronchiole RB, this is called alveolar duct AD, and this is called the alveoli AV. So always only remember RB, AD and AV, these are only respiratory zone, or you can say exchange zone. These are only respiratory zone or EX zone or exchange zone. All right. Next, inspiration can occur if the pressure within the lungs, intrapulmonary pressure, is less than the atmospheric pressure. Yes, it is true, and this is called negative pressure inspiration. This is called negative pressure inspiration. Atmosphere का जितने भी pressure है, that lung is having the 2 to 3 times negative more pressure in the lung, then only the inspiration would be happen. That's called negative pressure inspiration. Positive pressure inspiration happening only for frog at the mouth area. I have already mentioned, right? Inspiration is initiated by the contraction of the diaphragm. Inspiration is initiated by the contractions of the diaphragm. Inspiration is initiated by the suppose this is the diaphragm, and inspiration is there. So inspiration, so if there is contraction of the diaphragm, so inspiration is initiated by the contraction of the diaphragm, which increases the volume of the thoracic chamber in the antero-posterior axis. I have seen most of the students are confused with this line. because they don't understand the concept of the anteroposterior lining. So you have to understand this is the anteroposterior lining, okay, anteroposterior diameter. Why so? Because when we are baby, when we were kids, when we were embryonic, in the embryonic stage, this we were lying like this, okay. So you can remember this is the anterior, this is the posterior. So anterior posterior diameter in respiratory physiology, in case of this chapter, what NCERT tried to write, that this is the anterior posterior. In NCERT has written this is the dorsoventral, okay. This is the dorsoventral, this is dorsoventral, this is dorsoventral, okay. This is anteroposterior, okay. Okay, all right. So that is true. Next, inspiration causing an increase in the volume of the thoracic chamber in the dorsoventral. That is also correct. Dorsoventral would also increase. By adding up a few respiratory volume described above, one can derive the various pulmonary capacity which can be used in clinical diagnosis. Correct. I hope you know that this popular graph and how the things are going on. I hope you know this. I hope you know this tidal volume. Above that there is IRV, below that there is ERV, there is with the residual volume. And with measuring all these volumes and capacities, there are a lot of disease like asthma, emphysema, their diagnosis we can make. So it is correct. The solubility of the CO2 is 20 to 25 times higher than the O2. It is correct statement. Okay, it is correct statement. The solubility of the CO2, hope you know that through the alveoli, the CO2 can pass faster. The CO2 can pass faster. That's why even the less pressure, hope you know this equation, del rate of diffusion is equal to rate of diffusion is equal to sigma into del P divided by T. Hope you know this equation, rate of diffusion. Always remember the sigma, that is the rate, diffusion coefficient for the CO2 is actually having the value 20 to 25 times more than O2. As a result of that, the del P, because the T is constant, NCERT has clearly written the thickness. If we consider the alveoli and if we consider the blood vessels, NCERT has clearly said 3 layers less than 1 millimeter. 3 layers less than 1 millimeter. Hope you know that this is the endothelium. Hope you know this is the alveolicus cell beta. And hope you know that this all three, there are 3 layers. NCERT has said that this is cellular, this is cell layer, this is and this yellow thing is the basement membrane. These yellow things are the basement membrane, not cellular. So please remember, sometime NCERT will ask you, sometime NEET will ask you the questions, how many cellular layers are there, how many non-cellular layers are there. So please remember the red colors are the cellular layers, and the in between them, these are the non-cellular layers. And including these 3 layers, the thickness, even including these 3, the thickness, remember, less than 1 millimeter. The thickness is less than 1 mm. The thickness is less than 1 millimeter is the thickness. Now this T is constant for CO2, O2, whether CO2 is going from here, O2 is going from here, the T is constant. So only you have to remember and you know very well that if this is the RBC, please remember that if this is the RBC, you know RBC will attract O2 and CO2 to the same intensity. Okay, so basically you have to remember that as the sigma solubility of the CO2 is more, for that reason the del P of the CO2 is not that much required. Hope you can remember the del P usually lies between 45 minus 40, only 5. Can you remember this? Can you remember this? The del P, like in the tissue or the venous side, is the 45 millimeter mercury is the CO2 pressure, and the arterial side is the only 40. So 45 minus 40, only 5 millimeter mercury is the pressure difference, and with that pressure difference also the CO2 transport is possible just because of this one, that the del P because the sigma of the CO2 is 20 to 25 times higher. Next, the diffusion membrane is made up of three major layers. I have already mentioned. Out of these three major layers, please remember that out of these three layers, two cellular, one non-cellular layers. The thin squamous epithelium of the alveoli, endothelium of the alveolar capillaries, and the basement substance in between them. So it is a true statement. Next statement, RBC contain very high concentration of the enzyme carbonic anhydrase, and minute quantity of the same is present in the plasma too. Correct. So carbonic anhydrase, I hope you know, that actually combines the O2 and CO2. That combines the water and CO2, forming the carbonic acid, carbonate, and then again breaking it. So you have to remember, RBC contain the very high concentrations of the enzyme carbonic anhydrase, and quantity and very less amount of present in plasma too. So carbonic acid formation is possible in RBC and in plasma both. And whatever the carbonic anhydrase will work, that is a bidirectional reaction. That is also true. Please remember, this carbonic anhydrase is the fastest enzyme. It works very fast in our it is the fastest acting enzyme, so the turnover number of the enzyme is very high. Another center present in the pons. So it is a question regarding the neural regulation of respiration. So we have to say that true or false. Another center present in the pons region of the brain called pneumotaxic center, that can moderate the functions of the respiratory rhythm center. To my all dear student, I want to draw the part of the brain. This is the part of the brain which is looking like the beak of the bird, known as a midbrain. I am writing midbrain. This is and the next, the swelled up part known as pons, and then there's an elongated part known as medulla. So please, all my dear students, please remember the midbrain, pons, and medulla. These three are known as a brain stem. So hope you know the brain stem. This is the brain stem. It is looking like a stem. I haven't drawn the cerebrum. I haven't drawn the cerebellum behind. And one very important fact, that in pons there are two centers, one above, one below. So I am drawing one above center. It is you write it is a PN, pneumotaxic center. One below, that is apneustic center. This both of the centers, they will control the rate of the breathing. They will control the rate of the breathing, not the rhythm. They will control the rate of the breathing. Please remember. And medulla oblongata, they will mainly control the rhythm of the bleeding. They will mainly control the rhythm of the breathing. They will control the rhythm of the breathing, because there are two centers, one present dorsally. Dorsally matlab which side is dorsal? This side is dorsal. Please remember, the swelled up part is ventral. So this center is called the ventral respiratory center. This center is called the dorsal respiratory centers. Both of the centers present in the medulla called rhythm controlling center. These centers are called rate controlling center. And one more thing, that rate controlling center situated above than the rhythm controlling center as per the location. So the rate controlling center can moderate the functions of the rhythm controlling center. So this is very important concept. So the rate controlling center, so all this higher center, they can moderate the functions of the lower center, because this is, after all, they will form the synapse accordingly. Now there is one important question, that just adjacent to this rhythm controlling center, there is a center, and that center is called central chemoreceptor. That center is called central chemoreceptor. What is their role? Central chemoreceptor. Please remember, central chemoreceptor, by the side of this central chemoreceptor, my blood is flowing. The same blood which is flowing through the different parts of my body, the same blood is also flowing through this part. I mean, through this blood, through this vessel. And the central chemoreceptor has the capability to sense, to realize that what is my RBC containing. So they can feel that what is the partial pressure of carbon dioxide in this blood. They can also feel the proton present in this blood. If this two things are high, then this central chemoreceptor will be triggered, and once this central chemoreceptor is triggered, as the rhythm center is very close nearby to this central chemoreceptor, the signal will be immediately passing into the rhythm center, into the ventral and dorsal rhythm center. So what is the mechanism? Again I am repeating, PCO2. So please remember, this is a very logical thing and you have to remember it logically. In my blood, somehow the partial pressure of carbon dioxide and proton has increased. That increased level of these two things will stimulate the central chemoreceptor present in the medulla oblongata. Then the central chemoreceptor, nearby to it is having the rhythm center that will be triggered, and once it is triggered, the ventral and the dorsal centers, they will send the signal to the respiratory muscles like the diaphragm, respiratory muscles like the external like the intercostal muscle. So they will be sending signals to the they will be sending the motor signal, because hope you know that these are the muscles, and if you are sending signals to the muscle, so the neuron has to be motor neuron. So am I clear to everyone? Okay, now what is the function of the pneumotaxic center? What they allow, pneumotaxic center, suppose you are taking the inspiration, pneumotaxic center will try to cut the inspiration and switch it to the expiration. So pneumotaxic center, if it is activated, pneumotaxic center is activated, then remember it will switch off the inspiration. It will switch off, SWITCH, switch off the inspiration. So and it will shift to the expiration. So if you see that all the inspiration are switching off to the expiration, so number of the breathing cycle, inspiration plus expiration is each breathing cycle, so number of breathing cycle will increase. So as a result of that, if pneumotaxic center is stimulated, breathing rate will increase. So please remember, breathing rate will increase. Am I clear to everyone? Yes, am I clear to everyone? So all right, hope everyone is there. Yes, Anurag is writing respiratory control. Okay, very good. So breathing rate will increase if pneumotaxic center is stimulated. Apneustic center is causing the deep inspiration, so breathing rate will decrease. Breathing rate will decrease with the stimulation with the apneustic. But who is higher? Apneustic center is higher. As the apneustic center is higher, so whose direction will be final instruction? The final instruction will be pneumotaxic instructions. So that's why God has placed the pneumotaxic to the topmost level, and that will mainly control the rate. Of breathing. Okay. Hope you know these values. These values are very important. Hope you know these values. Just to remind you all, please remember, in the alveoli the values are 104 for oxygen. First let me complete the tour of oxygen. In alveoli the value of oxygen is 104 millimeter mercury. Pulmonary vein is also 104. Then this good blood is coming also 104. But when in the arterial side it will reach to the 95 level, and then the oxygen will be given to the tissue and it will become the 40. This 40 millimeter mercury oxygen will reach to this vena cava, and this to, and it will go nearby to the alveoli. It is having the 40 millimeter. Now the vein, this is the venous blood obviously now, so it is having the 40 only. This is 104. So 104 and here is 40. So the constant oxygen would be coming, and it will be again becoming the 95 after exchanging. Are you getting me? So oxygen tour is covered. Oxygen tour is done. Now CO2, carbon dioxide tour. You remember the carbon dioxide present here is the 40. Okay. Carbon dioxide present here is the 40. Here is also the 40, 40, 40, 40, 40. The thing is that once you are adding the constantly CO2, the carbon dioxide will not remain 40. It will become just 45. The same 45 of the carbon dioxide will move to here, and now here you have 45 CO2, here it is 40 CO2, so you will releasing some amount of the CO2 to the alveoli. So it's a very simple game. Most of the figures, important figures, are either in 104 or 95 or 40 or 45. Okay, so whatever be the answer of such questions, it will lie between either 104 or 95 or 40 or 45. And you got the logic as well. So just you do a oxygen tour once and you do a CO2 tour once, you will be able to recall the values of the pressure. So just let us feel this thing. Let us feel. So respiratory gas, if I say atmosphere, I am feel atmosphere में आपको ये I hope you know that is 20% of the O2, and you know in the atmosphere there is 0.04% of the CO2. Here's a trick: you can multiply with 8 and you will get the value in partial pressure. So I can say this is the 115.59 millimeter mercury, and this will be almost 0.03 millimeter mercury of the CO2 at atmosphere. Alveoli we have already talked about. This is 104 and this is the 40. This is the 40 only. Okay, this is the 40 only. Whenever I'm talking about the deoxygenated blood, you know CO2 is 45 and O2 is 40. O2 is 40. Hope you can remember deoxygenated blood went to the alveoli with the 40 millimeter mercury. All right. Okay. And next, if you talk about the oxygenated blood, so in oxygenated blood, you know it is maximum, it can reach the CO2 or oxygen concentration 95, and CO2 in oxygenated blood that we can maximum get up to CO2 in oxygenated blood, that is also 40, because I have already told you the 40, 45, 95, this will be the figure. In the tissue, the CO2 will be obviously 45 like the venous side, and the oxygen will be you know, at the level of the tissue, the oxygen will be just after the exchange, it will become the 40. All right. Okay, one more thing I want to say. Very easily you guys answered this, that what is the pressure of O2 and CO2 and CO2. But if I take 100 ml of the arterial blood and 100 ml of the venous blood, can you tell me that out of this 100 ml, out of this 100 ml of the blood, can you tell me what is the amount of the oxygen staying here? The amount of the oxygen staying in the arterial blood is the 19, and the amount of oxygen present in the venous blood is the 14. So what is in each 100 ml blood, when each 100 ml blood passing through the tissue, what amount of the how much ml of the O2 is consumed by the tissue? The answer is 5 ml. The answer is 5 ml. Please remember this thing. Similarly for the CO2, and what is the application? The application is that by calculating this amount, that how much ml of the blood, is passing to the tissue when 100 ml is passing, we can also calculate what is the oxygen consumptions per minute. What is the oxygen consumption per minute? Because we know 5,000 is supposed to go in a minute. 5,000 blood is supposed to go in a minute surrounding this tissue. So when 100 ml is passing through it, 5 ml is consumed. If 5,000 blood is passing through it, so when 100 ml is passing through it, 5 ml is consumed. If 5,000 is passing, which is actually because per minute we know 5,000 ml of blood passes through our body, so that becomes 5 by 100 into 5,000, and it becomes near about 250 ml of oxygen. So 250 ml of oxygen is taken by this tissue. Similarly for the CO2, if you see, this is 19. The CO2 here is actually 48 ml CO2 per 100 ml blood, and the CO2 here is 52 per 100 ml blood. Okay, 52 per 100 ml blood, 52 per 100 ml blood. So how much CO2 is you know, how much CO2 is added here? 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 Can you tell me how much CO2 is? So 5 ml is consumed here. How much CO2 is added here? So remember, the CO2 added is, it is 48, it is 52. So when 100 ml blood is passing here, 4 ml CO2 is added. And the same way when 100 ml blood passes through the tissue 4 ml, 4 ml, 4 ml. When 100 ml blood passes through this, 4 ml, 4 ml, 4 ml CO2 is added. Now the same thing, if 5000 ml blood passes through this, so 4 by 100 into 5000 ml of CO2 is adding into the blood, and that comes around 200 ml. Can you remember in the chapter excretion? In the chapter excretion, NCERT has written per minute how much percentage of, can you remember in chapter excretion NCERT has written how much percentage of CO2 is produced per minute? How much percentage of CO2 is produced by the lungs per minute? That is also 200 ml. So this is how the calculation comes. Hope my dear students have clearly understood the concept. This concept is important. This entire concept is very, very important, because there are a lot of numeric values, but you can remember it. It's not that you cannot remember. It is easy to remember. It is very, very easy to remember. Okay, it is very easily we can calculate. The question may ask you regarding the partial pressures. Even the question may ask you regarding the mLs and all these things. All right. Next biomolecule. So let us talk about the biomolecule: macromolecule, micromolecule, intermediate molecule. I have already explained an AIF. All this concept is already done previously. Hope you can remember that during the blood and body fluid, I have already made a table, and I have told you that how to differentiate the macromolecule, micromolecule, and all these things. Now this table is very important. You have to remember that the sequence, especially this is the most advanced, what is the element in our body, which one is most common? You can see that oxygen is most common next to the oxygen, because in water also oxygen is present. Next to the oxygen, what is present? That is the carbon. Next to the this is the hydrogen. Okay, this is the hydrogen. Okay, this is hydrogen. I think in older NCERT it is written as 0.5 na. Okay, in older NCERT it is written 0.5, I think. Okay, next to that, this is OCHN. Next to that is OCHN. Just you remember up to this. In one NCERT it is written 0.5, so that time you can write OCNH or OCHN. What is written in your NCERT? Just you check. This is December NCERT. Only it is changed in December 25 edition. If you have a edition December 25 onwards, then only you can tell this. Do you have the edition December 25 onwards? Please then tell me. If you have the edition, what is written at your edition, then it will be just opposite. That's why I'm asking. If you have an edition which is before the December 25 and it is written 9.5, then it is very sure that after December 25 it is changed into 0.5. That's why I'm asking. Okay, by this time being, okay, this table is copied in the same table. Okay, this is same table. Okay, then forget about this. Same thing. Okay, all right. Okay, someone has written Swarnadeep, sir, কয়েকটা true false statement বাকি রয়ে গেল. Okay, I think no. All the true false statement I think we have done. Let me check. Right. A chemosensitive area is situated adjacent to the rhythm center, which is highly sensitive to the CO2 and hydrogen ion, correct? But not sensitive at all to the low oxygen. Receptors associated with aortic arch and the carotid artery. Okay. Aortic arch and the carotid artery they recognize the changes in the CO2, changes in the proton, and send the necessary signal to the rhythm center for the remedial action. बिल्कुल सही. It is absolutely correct. You have to remember this is the aortic arch, and if I draw the carotid body, I can draw the carotid body, and you remember that this is the carotid body. Please remember this is carotid body, this is the aortic arch, and from here you are actually sending signal. From here you are actually sending signal to the medulla. Can you remember? At the medulla we had a center? Yes, in the medulla also. Actually, this is 9th cranial nerve and this is 10th cranial nerve. So these are all originated from here. So you know very well, you are again stimulating the medulla oblongata. Though you know there is a separate chemoreceptor of medulla oblongata already there, and nearby to it you have nearby to this you are already having the VRG and DRG. Already you have this. So please guys, please remember, this is how the aortic body and carotid body, this is something called, tell me, aortic. This is how the aortic body, and this is how the carotid body, they are also working, they are also stimulating the medulla oblongata in such a way. All right. Next, the role of oxygen in the regulation of the respiratory rhythm is insignificant. That is true. That's why in ICU setup we intentionally keep some CO2 in the blood of the patient so that the patient can trigger its own respiratory rhythm center as well. So much dust is produced in the defense mechanism of the body cannot fully cope up with the I think this is occupational lung disorder. So hope you know this is a right statement. Okay, next we are moving to these structures. You have to remember the name of each and individual structure. These structures are very important for exams. Please remember this is lecithin molecule. How to identify the lecithin molecule? See, this is these are the mostly palmitic acid, though it may be changing, but it is mostly palmitic acid. These are fatty acids. Both can be same, can be different, but the important thing is that both are fatty acid. This is fatty acid, this is fatty acid. Here it is phosphate, and this is the choline. Hope you know this is the choline. Say okay, CH2, N, CH3. So this phosphatidylcholine molecule, lecithin molecule, it is present on the cell membrane. It is present at the outer leaflet. Cell membrane, I hope you know cell membrane is having two layers. It is the outer leaflet. This is called inner leaflet. Inner leaflet has phosphatidylserine, something different, but outer it is called a phosphatidylcholine. This one, exactly this molecule is present at the outer leaflet of the membrane. Inner leaflet is having different type of the lipid that is called phosphatidylserine. Okay, and lecithin is also present in the bacterial cell membrane. In any cell membrane, lecithin is present. Lecithin is also present. There is called alveoli. In alveoli, please remember there is something called surfactant. It is very important to keep the surface tension low. Otherwise, the surface tension, as per the physics concept, surface tension will always work to the center of the, the circle. So more surface tension will lead to the collapse of the alveoli immediately after the expiration, which we cannot expect. So as a result of that, this surfactant is there. So you have to remember there is something called surfactant. So there is this molecule is called surfactant. So please remember surfactant is also lecithin. So these are the common function of the lecithin and common location and purpose of lecithin. Next, this is called the, when this is fatty acid, that is fatty acid, and the third one is also fatty acid, not the phosphate and the choline, then it is called the triglyceride. So please remember the triglyceride. This is the cholesterol molecule. How to remember? This is aromatic. This system is called phenanthrene system. This system is called the phenanthrene system. So you have to remember this is called cyclopentane. So cyclopentane and phenanthrene system, and this is the hydro. So this is called parhydrocyclopentanophenoanthrene ring. This is called parhydrocyclopentanophenoanthrene ring, which is cholesterol. This is the steroid. This group is called the steroid group. The same steroid group is also present in the progesterone, in the estrogen, in the aldosterone, in the cortisol, in the cortisone, then DHEA, dihydroepiandrosterone, any sterone, vitamin D, because that is also called cholecalciferol. So in all these things you will find this same group. Now what is this thing? This is the uracil. This is the uracil. So this is uracil. You will see NH group at the first and the third position. Hope you know nitrogen is located in case of, this is purine or pyrimidine. The structure is small, name is large. So this is pyrimidine. You remember, this is pyrimidine. From childhood days we used to remember that purine structure is small, name is small, structure is big. For pyrimidine, structure is small, so name is big, that is pyrimidine. Okay, now the locations of the nitrogen is the 1 and 3rd that you can see. These are the locations of the nitrogen. And one more thing, the 5th carbon is very important here. This is the 5th carbon. This is unique for the RNA. This is unique for the RNA. If you have uracil, that is definitely RNA. At this place, if you have methyl, then it becomes thymine. So, and that is unique for the DNA. So just a small change, that's why it is called 5-methyl uracil. So this is uracil, and if I add a methyl group, that will become thymine, which is integral part of the DNA. Acidic amino acid, basic amino acid, neutral amino acid. Guys, please remember, acidic amino acid are those amino acid when you will find the COH group, number of COH group is more than the NH2 group. In any amino acid, if you see COH group are more than NH2 group, these are acidic amino acid. You can say glutamic acids, you can say aspartic acid, any amino acid if you having the more COH than NH2. Basic amino acid, it is mainly questions of the chemistry, but still you have to remember because it is very important. Parhydrocyclopentanophenoanthrene, very good. So basic amino acid, when you will see that NH2 group is more than COH group, and that you can see in HAL. HAL matlab histidine, arginine and lysine. Out of this histidine, arginine and lysine, histidine and arginine, these two are called semi-essential amino acid. I don't know whether you are aware of not. These are called semi-essential amino acid. Please remember guys, these two are called semi-essential amino acid. Why it is called semi-essential amino acid? Why it is not fully essential? Because histidine is present mainly in the chota bachcha. It is required, and arginine is mainly required during the time of pregnancy. So that's why these are semi-essential amino acid. Anyways, neutral amino acid, lot of amino acids like glycine, like alanine, where you can see even phenylalanine, like this kind of like serine. Okay, you have to know the detailed structure of all these amino acid. Okay, in NCERT it is clearly written. In NCERT it is clearly written that clearly the pictures are drawn, and you have to also remember. Hope you know that in the beta chain, the mutations and all these things, there is a change that glutamic acid replaced by valine, GAG to GUG in the mRNA level, and thereby you can easily predict that change at the DNA level. At the 6th place, the valine, that's why the valine is present in beta chain in the 1st position and the 6th position. You might be surprised that in the 1st position it should be methionine in beta chain, because every polypeptide chain synthesis starts with the methionine. Always remember, in case of the beta chain, the methionine is replaced by valine as well. That is normal. But the 6th, even in the 6th, glutamic acid replaced by the valine, that is only danger, that is only not normal, and that is actually sickle cell anemia. All right, amylose, amylopectin, glycogen, relation to the iodine reaction. Wonderful question, wonderful concept. Let me draw. Just you draw, in case of amylose, you draw this, spring-like structure. The amylose is present in this such spring-like structure. And I am just putting the glucose, and you just try to follow me that how the glucose I have drawn. All these green molecules that I have drawn here, these are actually the glucose I am drawing. And you might be surprised that they are not forming like the branches and all these things. They are just doing the helical structure. Yes, absolutely correct. Amylose are only attached with the help of alpha 1,4 glycosidic bond, and they are forming the spring-like structures only. And what about the amylopectin? Amylopectin, guys, please remember, amylopectin, they are very branched. Okay, they are forming the straight chain and their side chain, straight chain and side chain. From the side chain, they're again forming the side chain. So amylopectin is completely different. They are like this. So this helical structure is missing in amylopectin. As a result of that, iodine trapping is best here. Iodine trapping is best in amylose, and that's why the characteristics dark color we get best in the amylose. In amylopectin, some iodine may get trapped and can give reddish brown color. That is not ideal iodine reaction. That is reddish brown is not ideal reaction. If I talk about the glycogen, the branching pattern is even more branched like this and this and this. It's more like amylopectin. And hope you know do you know carrageen? Do you know carrageen? Do you know carrageen? What is carrageen? It is something that is present on the cell. Do you know that is present? Carrageen is present on the cell wall of the green red algae. Carrageen RR, you remember R, Jada R red. But I want to ask, what is Floridian starch? Floridian starch, again Floridian R red algae, that is a storage material. Floridian starch, it is not actually starch like, because in the starch, this molecule is present almost 15%. Okay, and thereby you are getting this helical structure, and 85% is present amylopectin. In case of Floridian starch, even less than 15% amylose is present, maximum amylopectin is present. Less than 15% amylose is present, maximum amylopectin is present. So Floridian starch will not give a very good amount of this dark color, rather less amount of dark color. And if I talk about the glycogen, we never ever consider like the reactions, iodine reaction for the glycogen. If I talk about cellulose, you might be thinking, Acha, what are the bonds present in amylopectin? Amylopectin, not only the straight chain bonds are present like alpha 1,4, but also alpha 1,6, that side chains are also formed. In glycogen also, alpha 1,4 and alpha 1,6. Now talking about another molecule completely different from this alpha things and not digestible in human beings, that is something called cellulose. In cellulose, there is also straight chain compound, no such side branch, and that is called beta 1,4. But no, even helix not formed here. At least helix was formed here. No helix is formed. So iodine reaction is also negative here. So iodine reaction good. So actual iodine reaction positive in the amylose molecule only. And in starch, what is the ratio? In starch, you remember, guys, please remember, in starch, the amylose is to amylopectin. Amylose into amylopectin, A is to AP. I have written in this way. Amylose is 15 and amylopectin is 85. So please remember, even this 15% amylose will give the dark reactions. Okay, even this 15% is more they can give. Now chitin monomer, it is N-acetylglucosamine. N-acetylglucosamine is the chitin. Okay, inulin, it is the fructose is the monomer. Now agar galactose is the monomer. Now cellulose,
glucose is the monomer. Peptidoglycan, NAG and NAM is the monomer. Primary, secondary, tertiary structure of the protein. The primary structure of the protein, only the bond present, peptide bond present, okay, nothing else. Secondary structure, in case of secondary structure, peptide bond is present and hydrogen bond is present, okay, and disulfide bond is also present. In case of tertiary structure, hydrophobic bond, hydrophilic bond is also called van der Waals force. So that van der Waals force is also present. There is also all the other kind of forces also present there. Protein helix is right-handed. Protein helix is right-handed. Okay, this right-handed, and DNA helix is also right-handed. Okay, DNA helix is right-handed. Hollow woolen ball shape is seen in that structure of the protein. Hollow woolen ball structure seen in tertiary structure of the protein. Tertiary structure of the protein. Acha, CO, CA, CN, PO, these are the bonds formed by. These are the bonds formed by. This is kind of, you know, condensation reactions. And this is done by, what type of reaction is this? This is called, this is done by, this is formed by ligase. Okay, this one the ligase. Okay, ester, ether, peptide, glycosidic, CC, CH, PN, these bonds are broken by, bonds are broken by hydrolase. Okay, hydrolysis. Next, all measurements and count of different DNA. So hope you know that the DNA, for DNA, hope you know that each stair, suppose this is stair 1, this is stair 2, each stair, the distance between two stairs is equal to 3.4 angstrom. Hope you know such 10 stair will cover one major group, one minor group. That means from here to here you will find 10 stairs, matlab 10 base pair, and that will be exactly 10 times of this, that is 34 angstrom. And always remember, two subsequent base, suppose this is one base, is next base, two subsequent base, because you know in the y-axis also it is like twisting like this, so it is covering 360 degree, is equal to 360 degree, so one base pair to the next base pair, the distance is, linear distance is 3.4 angstrom, and the angular distance is 36 degree angle. Clear? Am I clear to everyone? Nature of the enzyme action. See the enzyme, how the enzymes are working. First you have to understand, this is the 3D structures of enzyme. Enzymes are in 3D and they have the site for allow the substrate to seat, and that site is called the site. It may be one substrate, it may be many substrate, that's not a problem. The site is called, active site. In this site, just below the active site, there will be something called, that is something called, you know, a cofactor. This is something called cofactor. Okay, cofactor. This cofactor can be metal, cofactor can be metal. Many a time the cofactor is metal. Even the cofactor can be enzyme. Okay, sometimes this cofactor is very tightly bound, and that is called prosthetic group, and sometimes loosely bound, that is called coenzyme. Okay, if said, let's say this is the coenzyme is NAD. Let's say the coenzyme is NAD. Always remember, NAD matlab niacin adenine dinucleotide. So there is a small niacin molecule. Let's say this niacin is the vitamin. In the same way, so vitamin can be a part of the coenzyme. Similar way, if riboflavin is a part of the FAD. Now, how the enzyme fulfill their function? First substrate bind with the enzyme. They form the complex called substrate enzyme complex. they form the complex called substrate enzyme complex. Once substrate enzyme complex is formed, what happens? There will be strong bond formation between substrate and the enzyme. This is a very strong bond. This is a very strong bond that forms between the active site of the enzyme and the substrate. Now what happens when the strong bond is already formed externally, internal lot of bond breaking within the substrate would happen, and substrate will be converted into the product, and that is called product enzyme complex. That is called product enzyme complex. Once the product enzyme complex is formed, automatically these bonds are broken. These bonds are broken. Once these bonds are broken, the substrate is converted into the product, it will not be able to remain attached to the active site. Automatically it will be freed from the active site. So you will get the product and the energy. You will get the product and the enzyme separately. You will get the product and enzyme separately because it is released out. Now if you see the kinetics is that this is the normal graph. Suppose the substrate is converted into the the product without the enzyme. With enzyme, what happens? With enzyme, this graph is following. The energy level remains same, substrate and product, but the EA, activation of energy, will lower down. Initially, if you see, huge amount of energy you were supposed to give, but now with energy, the lower amount of the energy you have to supply to get the product. So this is the purpose. Here is the role of to lower down the activation energy. This is the initial activation energy. This is the final activation energy. This is the activation energy without enzyme, and this is the activation energy with enzyme. This is the activation energy with enzyme. So enzyme has decreased the activation energy only, not the substrate energy, not the product energy. Next, competitive, non-competitive, uncompetitive, and enzyme class. First, I want to say the enzyme class OTHLIL. OTHLIL. What are the classes? This is class 1, class 2, class 3, class 4, class 5, and class 6. Total 6 classes of enzyme. Examples are definitely there. Oxidoreductase is the mainly all the dehydrogenase enzymes are oxidoreductase enzymes. Next, transferase, aminotransferase, peptidyl transferase, all transferase. Hydrolase matlab all the the enzymes like amylase, protease, lipase, nucleosidase, nucleotidase. This is called lyase. Lyase is the best example is the decarboxylase. Decarboxylase is the lyase, where the suppose a compound is having COH, automatically without the absence of the water it is broken. So that is actually called the lyase. So it is hydrolase in presence of the water bond breaking. Lyase is the in absence of the water bond breaking. Now the isomerase, this is the isomerase, lot of isomerase enzyme you already know. This is the ligase. In the movie we already know that at the last scene there will be always a peak moment. At the last scene there will be ligate, there will be meeting between the hero and the heroine. So some students are always confused between the first L and the last L. So you can remember in this the last L is the ligase. Okay. Now in any enzyme we can designate, suppose in such a way, in a digit, like a roll number. In your NEET examination you have such a roll number. For your enzyme classification also you have a roll number. The first one will designate the class, the second one will designate the subclass, but the subclass are 4 to 13 subclasses are there for each enzyme. Some enzyme is having 4 subclasses, some enzyme is having 13 subclasses, but that is not in your syllabus. You have to just say up to this information only. Now competitive, non-competitive, and uncompetitive. Competitive, non-competitive, and uncompetitive. So competitive is like, suppose this is the, you have to remember competitive is the, what is competitive? I have already posted a short. I hope you have seen that short earlier because I have posted that already. So competitive matlab, this is the most important. So today I will explain the competitive only. I will not explain the non and un. I have already posted in another short. You can search in my channel. In this channel you can already see that what is non and what is un. I have already posted earlier. That is not that much important for NEET exam. That for the NEET exam, competitive is most important. So what happens in competitive? In case of competitive, you remember this is the original substrate. This is the original substrate, but somehow you have given the another substrate which is very exactly same, that is the substrate molecule, which is known as inhibitor. As a result of that, it is very obvious that the original substrate, they are just staying at some distance and but not able to occupy the active site. Now what is the problem? The problem is that we are not converting the you are supposed to convert the substrate into product, but as it is inhibitor, you will not get the product. So you are actually wasting the enzyme. But enzyme is not able to realize it, that they are bound with something wrong things. Now the question, examples. What is such example? Example of such enzyme is the succinate dehydrogenase. Example of such original substrate which is supposed to get bound here is known as succinic acid. The product that we are supposed to get from here, we are supposed to get the product is known as Fa, that is the fumaric acid. So basically this enzyme converts the Sa to Fa. This enzyme converts the Sa to Fa, succinic acid to fumaric acid. Next, here in the active site, we know that there is another coenzyme. The name of the coenzyme is actually FAD. The name of the coenzyme is actually here FAD. Name of the coenzyme is FAD. You know, in the FAD, what is the vitamin present? Vitamin B2 or riboflavin is present. But the actual fact that you have to remember, that when Sa is converted to Fa by the succinic acid, then there is one inhibitor. That inhibitor is known as a malonate. So guys, please remember that here it is the seat of this person, that is the succinic acid, but malonate is blocking it. So malonate is not allowing this one to bind here, because both of them cannot bind at the same time. So but the enzyme is not able to realize, again the same problem. So the affinity, if I say, this is a very important word, affinity to the original substrate, it is reduced. Affinity is original substrate is reduced, number one. So in competitive inhibition, affinity to the original substrate is definitely reduced. What's next? So as a result of that, you have to apply more and more substrate concentrations you have to give more and more this yellow color thing to remove this one inhibitor from here. So that's why you have to increase the substrate concentration, and increasing the substrate concentration obviously increase the Km, because in the actual graph we know that this is the actual graph, this is the Vmax, hope you know, this is called the half Vmax. The half Vmax is reached at certain concentrations of the substrate, and that concentration is the Km. So substrate concentration is Km, at which we will achieve the half Vmax. Okay, this is the full Vmax, this is the half Vmax. So half Vmax had achieved a certain concentration called Km. Okay, now in this condition, can we achieve the Vmax? Yes, we can achieve, but for that reason the graph will form a different trajectory. The graph will be little bit like this. Why so? Because every time as someone is already occupying the active site, to get the same speed or same rate of product, we have to apply more and more original substrate. So obviously for the half Vmax also we have to give more and more substrate concentration. So the half Vmax, so the K, so that was the initial Km, that's the final Km. So you can see the final Km is also increasing. Number 3, can we achieve the Vmax? Yes. So the Vmax of the original white graph and the inhibited added graph, both are same. So Vmax will remain same, but you have to add more and more substrate. So what is the solution? So how we can get the Vmax even in this yellow graph? The answer is by adding more and more substrate. If we add more and more substrate, by adding more and more substrate. So if we add more and more this substrate, then this malonate inhibitor will be removed from the active site. Am I clear to everyone? Am I clear to everyone? Next, we are going to the next topic, that is a cofactor, coenzyme, prosthetic group, and metal enzyme. So please remember, it's a very simple thing. A very simple thing, not that much difficult. You just remember this is the enzyme, protein enzyme. This is the apo enzyme. The protein part of the enzyme is called the apo enzyme. And you remember that in this apo enzyme, with this apo enzyme, something is already bound there, that is called cofactor. That is called cofactor. If this cofactor is very tightly bound, that is called prosthetic group. Very loosely bound, called coenzyme. The coenzyme can be NADFAD. The prosthetic group can be heme of few enzymes like catalase, peroxidase, like this. Now metal enzyme is the metal. Okay, so not very difficult, just to remember the difference between this. Now excretory product and their eliminations. Now the next chapter, excretory product and their elimination. So what are the types of the nitrogenous waste? Hope every student knows. What are the types of the nitrogenous waste? Beta, nitrogenous waste are, it can be ammonia. Okay, it can be ammonia, it can be urea, and it can be uric acid. These are the three things. Ammonia is mainly aquatic and water soluble organism. Urea mainly in the land living organism. Uric acid is very unique to, one is insecta, second is the land snail, okay, third is for reptilia, and fourth is the avis. You just remember this 4 name for uric acid. You just remember 4 name for uric acid. Okay, you just remember for 4 name. Land snail, other snails they are urea. Okay, only land snails are this. And if I talk about in the fish, if I talk about the fish, they are ammonia. Only one fish urea. So that's why it is important. That is chondrichthyes. Shark, that is only the urea. So I have otherwise all the land living things like frog. If I say frog can do both. In tadpole condition ammonia, and adult frog, I should write that adult frog word. Adult frog is the urea excretory. Yeah, and human obviously, mammals also. So all the classes I have covered. Aves here, mammals here, reptilia here, frog here, fish here except chondrichthyes, frog here, but tadpole here, okay, tadpole here. So I hope everything is pretty clear to all of you. Next, excretory organ in different animals. I hope you have read that thing. You revise once more. This picture is important for NEET N26 in the black and white. Again and again I am repeating. The right sided structure is the, so just to remember, right sided structure in our body, vena cava, vena system is IVC, is present in the right, and you remember the left side system in the aorta system. So this is the dorsal aorta. This is the left side system is the dorsal aorta. Okay. Now you know the kidney. Hope you know this is the, this is the kidney. What is this? Okay. Oh, what is this? Okay, what is this? Okay, so what is this? These are called medullary pyramid. These are called medullary pyramid. So in between two medullary pyramid, there is something called column of Bartins. So hope you know column of Bartin. This is called the column of Bartin. This area is called column of renal column of Bartins. This is called Bartins column. In the NCERT, at one place it is written renal column, another place written column of Bartin. Students are confused, both are same or not? Both are same. So column of Bartin is actually the place between two two renal pyramid. And also remember, this area is called the actually renal column or pyramid. Sorry, this is renal column or column of Bartin. This is actually considered as cortex. This is actually considered as cortex. Okay, this is actually considered as cortex. Am I clear to everyone? Okay, very good. Great energy. I have seen many students, they are having great energy. Okay. Okay, so this is called renal. Actually, renal column is the cortex, because the cortex is somehow they are entering here. That is the concept. Okay. Next, what is this area? This is called the renal pelvis. This area is called the renal pelvis. Okay, 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 okay. In a pyramid, this is called the base of the pyramid. This area is called the base of the pyramid, and this area is actually called the apex of the pyramid. So don't get confused between the apex of the pyramid and the base of the pyramid. So this is the base of the pyramid. This is the apex of the pyramid. Please remember the apex of the pyramid. From the apex of the pyramid, minor calyces start. You can see nicely. You can see from the apex of the pyramid. From the apex of the pyramid, what happens from the apex of the pyramid? From the apex of the pyramid, please remember the minor calyces. Minor calyces. Please, guys, please remember. It's a very important. Just few days after you have exam, please remember. Okay, so this is the minor calyces. Okay, minor calyces. The minor calyces. Okay, minor calyces. So apex of the pyramid will be received by the minor calyx. Our minor calyx will fuse to form the major calyx. Three major calyx are there. Okay, okay. Upper major calyx, middle major calyx, and lower major calyx are there. Okay. All right, all right, all right, all right. Here in the picture, the vasa recta is very important marking. Everyone should remember. And with this picture, obviously we have to remember what is called counter current multiplier and counter current exchanger. I'm saying this vasa recta is the counter current multiplier. No, it is a counter current exchanger. It is a counter current exchanger because the counter current multiplier. Because the counter current multiplier is the loop of Henle. Counter current multiplier is actually loop of Henle. Counter current multiplier is the loop of Henle. Loop of Henle is the counter current multiplier. Okay, so function of the different part of the nephron is very important. Proximal convoluted tubule, distal convoluted tubule. You have to just remember the function between the proximal convoluted tubule and the distal convoluted tubule. Proximal convoluted tubule, you have to remember what are the things absorbed from here. You know 100%, 100% of amino acid is absorbed. 100%. Please give your attendance in the comment. Let me see how many of you are present. Give me please give me your attendance. Please give me your attendance in comment. Let me see how many of you are present. So this is amino acid, this is the glucose. So 100% amino acid, 100% glucose are absorbed. See the arrow, guys. See the arrow. The arrow, if you see the arrow towards blood, that means reabsorption. And if you see that arrow is towards the renal tubule, that is secretion. So you have to remember which one is absorption and which one is secretion. Okay? So this is the this amino acid and glucose 100% absorption from the PCT, and that is also actively. Remember 65% of the sodium is reabsorbed. 65% of the sodium is reabsorbed from here. And also remember the water. Also remember the water. Also remember the water. Also remember the 65% of the water is also reabsorbed. So 65% water, 65% sodium is reabsorbed. Okay, from the PCT. Okay, 100% of the amino acid is reabsorbed. Next, 100% of the glucose is reabsorbed. Okay, and secretions, if I and also bicarbonate, if I talk about the bicarbonate, you remember the bicarbonate. So you remember the bicarbonate, that is also reabsorbed from here. The bicarbonate is also reabsorbed. Okay, on Oniket is good night. Okay, Swarnodeep says shesh obdi thakbo. Achi sir, Swarnodeep is saying. Okay, okay. Ritam is here. Ritam, bapre. Ritam is here. Very good, Ritam. Okay, so these are the absorption in the PCT. If I talk about the secretions from the PCT, you remember the PCT. Anytime secretions means potassium will be secreted. Okay, anytime secretion, matlab abhi only we are talking about the PCT. I have not changed the part of the nephron. We are still talking about the PCT. Potassium is secreted out. H plus is secreted out, and the proton is secreted out. Okay. proton is and ammonia is secreted out. So potassium, ammonia, and these potassium, ammonia, and proton is secreted out. Okay, proton is secreted out. Now we'll talk about the loop of Henle. So hope you know the loop of Henle ka funda. Loop of Henle ka funda is very important. The descending, they are permeable to the water, and the ascending, they are permeable to the ions. So the descending, if we go down and down and down, you know, all the ions are coming out, and as a result of that, as all the ions are coming out, so initially it is the 300, then inside 600, inside 900, and finally inside 1200. Okay, inside 1200. So sometimes we say that 4 times concentration has happened. And then here, and how it is possible? By removing the water outside. The removing the water outside, it is permeable, water permeable. Now ascending, just opposite, ion permeable. So you can see that ions you are losing, and you might be surprised that again the concentration will drop. You might be thinking, then what is the purpose of doing this net gain zero things? Don't worry, that's why we have, and the last part, that is called the DCT. And you can see the DCT, you can see the DCT, what the DCT will do. DCT will absorb, DCT. Acha, hope you know that the PCT is having the cuboidal epithelial cells with brush border. Hope you know these are cuboidal epithelial cells with brush border. Brush border is a cell membrane modification. So please remember, brush border is a, okay, Shomarjo, okay, Shomarjo, very good. Shomarjo is saying Amio Achi, very good. So this is actually microvilli. This is actually microvilli, or you can say brush border. So this is brush border or microvilli. This is cuboidal epithelium. Okay, this cuboidal epithelium is present here. So I'm just putting the arrow so that you can understand. This is the cell that I have drawn. Okay, here in a magnified way. So cuboidal epithelium. Now I want to say here also you will be finding the same cuboidal epithelium with the brush border, and here the functionality is a bit different. Here there is a small water channel. This water channel is called aquaporin, and to form this water channel, it's very, very important to have the hormone called antidiuretic hormone or vasopressin, which is coming from the posterior pituitary through the blood. And this ADH will form the water channel, and with this water channel, you know, the ADH will be passing into the blood vessels. ADH will be passing to the blood vessels. Once the ADH is passing to the blood vessels, your urine will be concentrated. Your urine concentration will be high. I just want to say, everyone, most of the student, they don't answer the ADH related MCQ in a correct way. I have asked many students, suppose you are visiting to desert, what will be the ADH level? Most of the students, they say, in the desert I will not be able to take water, so the ADH will be dropping. No, it's wrong. It's wrong. Suppose I am saying what will happen at the winter time. You are in chilled mode. So most of the students are saying that in the chilled mode I am not losing water. So I'm like at that time the thing will be something different. So it's not that how much water you are intaking. It's important that what your blood concentration is saying. So whenever you are answering, let's say it's a scorching sun. Let's say it's a scorching sun, and your blood, just you imagine this is your blood. So whenever you are sweating, your blood is losing water. In scorching sun, your blood is losing water. Okay. So your blood concentration will be increasing. I hope you know pi. Pi is the osmolar concentration. So if osmolar concentration is increasing in your brain, there is a center which will sense that yes, the osmolar concentration has increased in the blood, and automatically they will try to maintain the homeostasis. You know, homeostasis. They will try to decrease the pi. They will try to again reabsorb the water and maintain this pi. That's why the ADH release will be increased. That's why the ADH release will be increased. That's why, because ADH release can only absorb the water in the blood. So guys, please remember, in desert, in scorching sun of summer, ADH will be increased. That is the funda. And all such MCQ we should answer by thinking about the condition of the pie, not like this, that whether the water is available to you or not. It's about the pie. Your body will release the ADH to maintain the pie. In the same way, suppose you are in a chilled mode, super chilled mode, in the winter, in a super chilled mode, okay? Super chilled mode, okay? This is, let's say, this is the snowfall. That time what will happen, let's say this is, let's draw this blood thing, and here it will happen, there is no blood loss. In super chilled mode there is no blood loss, so water will be staying here. So what will be the pi? The pi, is it more? No, the pi is less, because still the water is here, you are not urinating, no urines and everything, nothing is there, so pi is less. What body will try? Body will try to not to intake water. They will try not to intake water. They will try not to intake water. Not to intake water मतलब ADH का कोई ज़रूरत नहीं है. There is no requirement of the ADH. So obviously ADH level will drop. So this is how you should answer. So every student should answer such questions from this particular regard only, like from the pi point only. You have to answer from this pi point only. You have to just think about the concentrations of the blood only. Don't think much more. Regulation of the kidney. Hope everyone knows that about the this is also one regulation. ADH is also having one regulation, that when the water absorption will be more or less. There are other regulation as well. There are other regulation as well. So guys, please remember, like 300, 600, 900 and 1200, again 300. So you might be thinking that what is happening by, and in fact not only 300, sometimes it becomes 100 also. So you might be thinking that 300 at the PCT was far better, because at the end of the loop of Henle we are getting 100. But don't worry, that kahani mein twist abhi baki hai, because the twist is that collecting duct, just you come and let the urine come to the collecting duct, lot of ADH will absorb lot of water, and finally you will get the urine concentration again 1200, which is exactly 4 times more than the blood concentrations. Hope you know that in our blood also we have the concentrations of 300 milliosmol. In normal condition our blood osmolarity is also 300. Okay, so blood osmolarity 300. PCT, some teacher may ask you this question: what are the osmolarity? Blood is 300. PCT, you can see the entire thing is 300. Okay, PCT is also 300. So it is isoosmolar. So iso matlab blood ke respect mein, whatever the concentration we are seeing with respect to the blood. So this is isoosmolar. This is again and again the descending is the, gradually it is becoming hyper. Gradually it is become hyper. Okay, gradually it is become hypo. Gradually it is become hypo. It is become hypo. Even it is hypo. DCT is even DCT even initial part hypo. Latter part of the DCT and collecting duct, again it is become hyper. So this is how the glomerular filtrate concentration is gradually changing. This is how the glomerular filtrate concentration gradually changing. Now talking about this regulation, this is here we are talking about the before the neural. Let's talk some part about the RAS. Okay, RAS. Don't forget guys, don't forget about the RAS mechanism. It's a very, very important mechanism. RAS is the renin, R-E-N-I-N. Don't say it is double N. Double N is the enzyme renin that is present in the stomach of the calf, the stomach in the baby cow and stomach in the human baby. That RE-double-N is present, and that is the enzyme that digests the milk protein. But here the R-E-N-I-N, renin, it is actually the hormone. It is actually the hormone, and that hormone is present from our kidney. That hormone is present from the kidney. Okay, now from the kidney this hormone is releasing. That hormone will ultimately go to the liver. In the liver there is a product called angiotensinogen. In presence of this one, in presence of this particular hormone, this angiotensinogen will get converted into the angiotensin. Will get converted into the angiotensin, and now this angiotensin. Now you remember, now this angiotensin, please remember, now this angiotensin, now this very good, Swarnadeep is saying right. Now this angiotensin will go to the lung. will actually this is actually not angiotensin 1 actually. So in the liver, now the angiotensin 1 from the liver, it is going to the lung, and and the lung is having one enzyme called angiotensin 1 converting enzyme, which will convert 81 into 82. So the exit product of the lung is the 82. Thus this 82 is directly stimulating the adrenal cortex. So I am just drawing the adrenal cortex. In the adrenal cortex is a triangular shaped gland. At the outer of the adrenal cortex, there is something called zona glomerulosa. So this zona glomerulosa will be triggered by the 82 angiotensin 2, and zona glomerulosa will be releasing another hormone that is called aldosterone. And that aldosterone is a steroid hormone that straight away will be working on the, hope you know this is called the distal convoluted tubule. In the distal convoluted tubule, there is there is a cell, and in this cell there is a channel protein. Hope you know that channel protein actually absorb the sodium, and it excrete the potassium. So that channel is triggered, that particular channel is triggered by the aldosterone. So what will happen, that in presence of the aldosterone, a lot of sodium will be absorbed from the urine into the cell and thereby into the blood. So if you have huge aldosterone, your sodium absorption will be high, and sodium is the water dragging, it has a water dragging feature, so it will also drag the water. So if aldosterone is high, so remember the sodium reabsorption will be high into the blood. That is called hypernatremia. Just last two chapter, okay, last one chapter, neural coordinations remaining, okay, just one chapter remaining, neural coordination. So don't worry about, okay, neural coordinations I need just 15 minutes, okay. So if aldosterone is high, then sodium and water reabsorption will be also high. If sodium and water reabsorption will be also high. So if aldosterone is high, sodium and water reabsorption will be also high. And the person will have high blood pressure. So you might be thinking, then why this kidney regulation started, this RAS mechanism started if there is low blood pressure. So if any person is having low blood pressure, how it is possible? Like a huge hemorrhage, like huge bleeding, huge vomiting, huge diarrhea, and the person is losing a lot of water from the blood, okay, in different ways, and then only the BP will go down and RAS will be triggered. So RAS is actually, you can see the controlling kidney control. Actually in the entire RAS, this is only the part which is controlling the blood pressure, okay. And if we have a good blood pressure, it actually helps to have the good GFR. matlab, I hope you know, this is the glomerulus. So glomerulus, if the glomerulus is having the good pressure, then the GFR, that is the glomerular filtration rate, which is usually 125 ml per minute, that will also increase. So this GFR will also increase. So that's GFR will be also increase. So if low GFR and low BP, the RAS is started, and that ultimately, and if once RAS is started, everything like the BP will be high again, I mean normalized again, from low to normalized, and GFR will be from low to normalized once again. So this is the funda that we have to remember. Last chapter, neural control and coordination, which is very usual and very normal. You have to remember, it's a very crucial chapter. Neural system, you have to remember, it's neuron and neuroglia. Both are forming. More than 50% is formed by the neuroglia, and neuron is less than 50%. Important thing is that which one is excitable? Neuron is excitable, neuroglia is not excitable. How many types of neuroglia are there? Neuroglias are microglia, oligodendrocyte, and astrocyte. 3 types of neuroglia are there. Function: microglia
do phagocytosis. Astrocyte forms blood-brain barrier. Anything present in the blood cannot come to the brain neuron. And third is the oligodendroglia, which forms the myelin sheath like swan cell. Like swan cell performs the myelination, here this oligodendrocyte performs the swan myelination. CNS versus PNS. CNS is, you have to remember, CNS is the central nervous system. Okay, CNS, central brain and spinal cord, that is the CNS. Okay, and what is the PNS? PNS is the, this one is the PNS. Okay, this one is the PNS. PNS is the peripheral nervous system. This one is the peripheral nervous system. This one is the peripheral nervous system. Now peripheral nervous system are of two types. If from the brain, that is called cranial nerve, and if from the spinal cord, that is called the spinal nerve. So peripheral nervous system is equal to cranial nerve plus spinal nerve. Central nervous system is equal to brain and spinal cord itself. Now each of this nerve that I have drawn in the violet color, remember the nerve may have maximum 3 types of category of neuron. One category of the neuron which is coming the sensation to the brain or sensation to the spinal cord, so that is also, that may be the part of the cranial or the spinal nerve. Okay, and one is a motor which is carrying out the signal from the brain or from the spinal cord, so that may be the part of the spinal cord or the cranial nerve. Third, which is actually carrying out the signal not to the skeletal muscle, to the smooth muscle or gland, which we cannot perform the function voluntarily.
No, সেটা না, চার্জ নেই।
বক্সটা ঠিক আছে।
No, no, no charge. Hello, audible? Is this audible? Hello, audible? Audible? So protein, audible? Yeah. So this is the swan cell. This is the nasal granule. They are made up of the ribosomes, RNA, mRNA, and RNA and ribosomes and mRNA. So basically, this apparatus actually, like mRNA, ribosomes, RAF, endoplasmic reticulum, they are clustered and forming the nasal granule. Now talking about the myelin sheath. So I just want to tell every student, they are confused about the concept of the myelin sheath. I want to say that this is the main neuron, and the main neuron, around this main neuron, Schwann cell is every time present. Schwann cell is every time present. Don't say Schwann cell is not present. PNS matlab Schwann cell is present. But the question is that the Schwann cell is doing envelope or enclose. The picture that I have drawn above, where the Schwann cell is present, but it is not doing the, it is actually what they are doing, it is actually enclose. It is actually enclose. But here you can see it is actually envelope. It is actually envelope. So Schwann cell present and envelope, then it is only the myelination. So this wrapping should be required. But here the Schwann cell present, but only just covering, enclosing. So here the myelination is absent. So please, your idea has to be very clear. Okay, your idea has to be very clear. All right. Okay. All right. Your idea has to be very clear. Clear? All right. All right. Clear? So you have to remember that. Clear? So the idea has to be myelination, enclose, myelination, envelope. Myelination, enclose, myelination, envelope. Myelination enclose matlab you have to remember the Schwann cell. Schwann cell present, myelination absent because it is only enclosing, not enveloping. And in the second case, Schwann cell present and it is also enveloping and myelination present. Example. Now we have to say examples. Now you have to say the examples. So examples for this one, for Schwann cell, you have to remember the examples of the myelination is the sensory neuron only. Sensory neuron, or sensory nervous system, you can say. Sensory nervous system. All right. And you have to remember for this one, you have to remember that this is somatic nervous system. See, actually somatic nervous systems are two types, somatosensory and somatomotor. Remember, somatic nervous systems are actually two types, somatosensory and somatomotor. Okay, somatosensory and somatomotor. So but in NCERT, the somatic sensation, like this NCERT has said the somatic in the sense of motor only.
So every time I do mention this thing in the class, that NCERT has mentioned that somatic matlab somatomotor. So somatomotor will be definitely non-modulated. Okay, okay. All right. Just it has to be reversed only. It has to be reversed only. So myelination, proper myelination, you write sensory here. And non-modulated, you write somatic and autonomic. All right, clear? Okay. Next one, generation and conduction of nerve impulse. So please remember that if this is the neuron, what are the signals generated? Positive signal, negative signal. For positive signal, you have to remember that suppose this is the channel, this is called sodium channel. Sodium has to be entered. If you want to allow the sodium entry, what you have to do? You need a molecule. What is the molecule? The name of the molecule is acetylcholine. How the acetylcholine molecule we can obtain? From neurotransmitter. So the neurotransmitter will be releasing the acetylcholine molecule. Okay, from synaptic vesicle you will get the acetylcholine molecule, and sodium gate will be opened. Once the sodium gate will be opened, positive charge will be entering inside the neuron. Once the positive charge is entering inside the neuron, obviously outside will be negative, and this is called just opposite of the normal situations. Matlab resting potential. In the resting potential, sodium concentration extracellularly high and intracellular sodium concentration is no more. I mean, intracellular sodium concentration is less. That's why relatively the potential, if you see normal condition, that is minus 70 millivolt. But only on that particular point where sodium has entered inside, the voltage, inner side voltage, inner membrane voltage will be higher even in the positive side. This voltage, if you remember this voltage, if you remember this voltage, if you remember this voltage will encourage this positive this positive voltage will encourage the next sodium channel to get opened. So you just have to remember this sodium channel is called ligand gated sodium channel, and this sodium channel is called voltage gated sodium channel. So again I am saying this sodium channel number 1 and number 2. The number 1 called ligand gated sodium channel, and this sodium channel is called voltage gated sodium channel, because in case of the first case the channel opened, due to the presence of, due to the presence of the acetylcholine. In the second case, the channel opened due to the presence of the already created positive voltage. Okay, now this signal will be carrying forward. You have to just remember the location where the myelination is present. Suppose these are the location where the myelination is already present. At that particular points, you remember the sodium channel is not possible to present. So sodium channel will be again present only those location where the myelination is absent, and in the same way sodium will be entering through this channel, and that will again create the positive voltage inside, and small currents will be created, and ultimately the signal will be reaching to the end, that is a synaptic knob. Okay, now it's all about the repolarization. So depolarization is only possible with sodium channel. Now repolarization you have to remember, repolarization matlab there is a channel which throws 3 sodium out and 2 potassium in.
3 sodium out, 2 potassium in presence of the ATPase, in presence of the ATP, breaking the ATP, getting the energy, 3 sodium out, 2 potassium in, and every time net 1 sodium charge is losing, 1 positive charge is losing, and thereby you are getting the net charge minus 70 millivolt. Okay, this is one mechanism. Sodium potassium ATPase pump, that is the most strongest channel which will give you the repolarization. So repolarization ka mechanism 1, I will write the repolarization in yellow color here, because because this is something I have already drawn depolarization at that area, at the above area. Now the second thing is that there is another channel called, potassium exit channel, and this is voltage gated potassium channel, because in presence of the positive voltage, the potassium channel will be open and the potassium will be exited from the neuron. And there is another potassium channel, there is no gate at all, so the potassium can move freely outside the neuron. This is called free potassium channel, or you can say non gated potassium channel. This is called non gated potassium channel. So I hope it is clear to you. Right? Okay, so today I have discussed, so we have discussed 3 mechanisms, that is sodium potassium ATPase pump, voltage gated potassium channel, free potassium channel, automatically all the potassium will be released out, and also some negative proteins are there in the exoplasm. So these are mainly 4 mechanism of the repolarization. Sodium entry, ligand gated, voltage gated, that is only the mechanism of the depolarization. So that's all for the today. I hope you have enjoyed. All the best to all of you. Okay, so today we have finished the entire zoology, mainly class 11 we have finished. Entire class 11 today we have discussed, and the most important crucial areas we have already discussed. If you want, okay, so biotech so biotech you want, if you want biotech, do you want me to tomorrow be live as well for your 12th Joe revision? Do you want? We have completed the 11th today. Do you want the for the revisions of the 12th for tomorrow? Okay, Shomarji is saying tomorrow is first. Okay, tomorrow. Okay. So I will talk to the team that whether the 12th duo is possible tomorrow. So then if it is possible, then I'll come tomorrow. Otherwise, I'll be giving a lot of MCQs to the Telegram channel PrepMed NEET by Dr. Debojyoti. At the Telegram channel, I'll keep posting the question. Okay. All right. Okay, Shomadev is saying that 12 botany, 12 alive. I think 12 botany, some questions were there. Na? There was one live, some questions were there. Right. What you are saying. Okay. So see, already in the mock test, a lot of questions are already being shared. If you practice those things, have you finished that worksheet that I have given to all of you? Like the most common mistake area. I have already shared that in the Telegram channel PrepMed NEET. Have you finished it? Okay, very good. So keep me writing in the Telegram channel that what kind of session you want tomorrow in the comment sections, and based on that I would be deciding that what type of session we should take tomorrow. All right. So for today we are finishing the session. All the best to everyone. All the best for your NEET preparation. All the best for 3rd May. Rock the exam. from my side. It's I think it's a long time that right. Okay, so we are waiting for a long time for such exam on 3rd of May, and it's national level examinations. Everyone should be very cool and calm. It's not that your next competitor knows more than you, or everyone almost have equal knowledge. It's all about how you are performing on the day of examination. Everyone has practiced the questions in their mock test, but it's important to stay cool and calm, and it's all about like how you are thinking at the point of examinations, during the point of examination, how you are thinking the questions, and how fast you can recall the things that you have solved at exam time, at a mock test time. All right, so today I'm ending session. Bye bye, good night, all the best to all of you.